Hello there and welcome back to the Sleep Science. Tonight, we're going somewhere no human body could ever survive for more than a few seconds, yet your imagination can. You drift downward through clouds the colour of tarnished gold, each wisp thick as soup and laced with acid so fierce it could strip paint from a jet mid-flight. The sunlight here bends strangely, scattering into amber ribbons that make even your gloved hands glow. You can't tell if it's dawn or dusk. On Venus, those words blur together into one long shimmering haze. Somewhere far below, an entire world hides behind curtains of poison and mystery. Once upon a time, astronomers peered through their telescopes and saw that this planet was almost the same size as Earth. They called it our sister world, and for a while they believed it might be filled with swamps, tropical forests, and maybe even dinosaurs. Ah, optimism. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're joining from somewhere new tonight, drop your location and your local time in the comments. I love seeing where in the world you're listening from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. As you descend through that honey-coloured soup, your senses start to scream. The temperature outside climbs past 400 degrees Celsius, hot enough to melt lead. The pressure builds to 90 times what you'd feel on Earth's surface. It's like being a kilometre under the sea, except the sea is made of carbon dioxide and the waves are pure fire. And yet, it's strangely beautiful. The clouds swirl in thick layers, pale yellow on top, deeper gold beneath, each tier whispering stories of chemistry gone feral. The first probes that tried to land here didn't stand a chance. They fried, crushed, or simply vanished before sending a single coherent signal. You remember the first human eyes that truly saw beneath those clouds belonged not to people, but to machines built by the Soviet Union in the 1960s and 70s, the Venera missions. Venera 7 became the first spacecraft ever to land on another planet and transmit data back to Earth. Though transmit might be generous. It lasted just 23 minutes before the heat cooked its circuits. Imagine spending years designing a perfect robotic explorer, only for it to survive less time than an average coffee break. Still, those few minutes changed everything. The dream of tropical swamps was replaced by a nightmare of pressure and flame. Even centuries earlier, Venus had captivated humanity. The ancient Babylonians charted her bright dance across the sky more than 3,000 years ago. The Maya called her No-Ek, the great star. To the Greeks and Romans, she was Aphrodite or Venus, the goddess of love. Historians still argue whether early astronomers truly believed Venus was a twin Earth or merely used that notion as poetic shorthand for something beautiful yet unknowable. Either way, the revelation that the planet was a hellscape shocked the 20th century's sense of cosmic optimism. Floating in your protective capsule, you can almost hear the echoes of those older dreams, the swampy jungles described in pulp magazines, where four-armed aliens hunted explorers through mist. In 1918, the science fiction writer Garrett Serviss imagined Venus as a paradise of gentle creatures under purple skies. A century later, we discovered the sky really is purple, but for entirely wrong reasons: sulfur, dust, and heat distortion. The colours of apocalypse, not romance. Still, there's something intimate about the way Venus glows. From Earth, she's the brightest natural object in the night sky after the moon. Early sailors used her as a morning or evening guide, hence her nicknames, the Morning Star and the Evening Star. You might have seen her too, that bright jewel hovering low on the horizon, too brilliant to twinkle. People once made wishes on her light, believing she carried messages from the gods. Funny how the same star that symbolises love is, in reality, the most violent place in the solar system. As your capsule falls deeper, the clouds outside begin to spark with faint light. It's like lightning, but not quite. For decades, researchers have debated whether Venus's thick atmosphere can generate electrical storms like Earth's. Some probes detected crackling radio bursts that could be lightning, others heard only static. Historians of science still argue whether those readings proved anything, or were merely artifacts of interference. Even here, among the acid vapours, mystery insists on surviving. A whisper of turbulence nudges you sideways. The wind speed here reaches hundreds of kilometers per hour, pushing your descent module as if it were no heavier than a leaf. Through the golden murk, a distant glow flickers, sunlight reflected off the upper haze. You realise the clouds themselves stretch for almost 20 kilometres of vertical depth. Somewhere above them, the air is cool enough that a human could, in theory, float in a dirigible. But that dream is for later. Right now, you're plunging toward the unknown. It's hard not to anthropomorphise a planet like Venus. She's Earth's twin in size, mass, and composition. If you held both worlds in your hands like marbles, they'd look almost identical. But somehow, one became paradise and the other purgatory. That duality fascinates planetary scientists. Two sisters born from the same cosmic dust, raised side by side under the same sun, and yet they took utterly different paths. Maybe it's a cautionary tale about climate, or maybe it's just the universe showing off its sense of irony. There's a faint rhythmic thumping from the descent capsule's hull. The pressure is now so immense that the metal groans like a deep-sea submersible. The viewports glow dull red, not from lights, but from the sheer heat outside. It's like descending into the heart of a forge, and yet you keep watching, entranced. A new world always feels like a promise, even when that promise is pain. Then, just as your senses start to dim, you glimpse a shadow through the haze, something solid, massive, and unyielding. The surface of Venus, or what passes for it. It's a land you'll soon see up close. Cracked basalt plains, strange volcanic domes, and valleys carved not by water, but by molten rock. But that's a story for the next section. For now, you hover in the golden twilight, caught between myth and reality, warmth and destruction. You exhale softly, the sound muffled by the hiss of life support. Venus has been waiting 4 billion years to be truly seen. Tonight, she's letting you in, just a little. You drift lower, the capsule rattling as Venus's infernal breath presses against its hull. The numbers on your screen blink red. 460 degrees Celsius outside, 92 atmospheres of pressure, like the weight of the entire Atlantic Ocean stacked on your shoulders. Welcome to the world's longest sauna, except the air here isn't steam. It's carbon dioxide so dense it could almost be poured. You can't help thinking of every well-meaning headline that once called Venus Earth's twin. Sure, if your twin spent her spare time sitting inside a pizza oven. The phrase runaway greenhouse sounds gentle, like something that might involve a rogue tomato plant. But in reality, it's the story of how Venus turned itself into a furnace. Billions of years ago, the sun was dimmer and Venus probably wore an atmosphere rich in water vapour. Oceans may have shimmered across its surface, shallow and warm, their waves stroking volcanic shores. But the planet sat just close enough to the sun that heat began to tease those waters upward. The higher the vapour rose, the more sunlight it trapped. The warmer the planet grew, the faster its seas evaporated, until the whole world became a feedback loop of boiling and burning. Carbon dioxide from volcanic eruptions joined the party, trapping even more heat. The last raindrop probably hissed into nothing long before life on Earth had fins. Historians still argue whether Venus ever enjoyed a true habitable era, or if it was doomed from the start, its proximity to the sun sealing its fate long before clouds had a chance to gather. A quirky little tidbit. Some models suggest that if Earth were nudged just a few million kilometres closer to the sun, it too could spiral into a similar runaway greenhouse. It's the universe's way of reminding you that comfort is conditional. You look down through the haze, watching as the light shifts from gold to the colour of old brass. The clouds seem to churn with a life of their own, thick convective cells rising and sinking like the breathing of some vast creature. Every particle of sulfuric acid acts as a tiny mirror, scattering sunlight in every direction, so even the shadows seem to glow. It's dazzling and oppressive. Somewhere above you, the carbon dioxide molecules are playing their cruel little trick, letting sunlight in but refusing to let infrared heat back out. They've built a perfect thermal trap, a planetary greenhouse that no breeze can ventilate. On Earth, the greenhouse effect is what keeps our planet warm enough for rivers and humans and coffee. On Venus, it's what turns every pebble into an ember. The surface temperature here never changes between day and night. The entire planet is uniformly hot, as if the concept of shade gave up long ago. Even the night side radiates at 460 degrees Celsius. You could leave an iron skillet outside for a minute, and it would glow cherry red, though you'd never make it close enough to flip a pancake on it. You remember one of those Venera photos, grainy, amber-toned, showing a flat plain littered with fractured rocks. The lander that took it lasted just over 2 hours, long enough to send back a handful of frames before the electronics melted into their own casing. The Soviets built those machines like tanks. They even preheated the internal components so the sudden surge of Venusian warmth wouldn't shatter them instantly. Imagine designing something meant to expect death as part of its operating procedure. A strange sort of bravery, that. If you squint through the opaque window, you can almost imagine what that surface feels like. Not fiery in the flickering sense, but heavy, oppressive, ancient. A place where chemistry itself seems exhausted. No water, no wind as we know it, just sluggish currents of carbon dioxide moving like syrup. Even radio waves crawl here. The heat bends them, slows them, distorts every signal until the planet's voice sounds tired and far away. And yet, despite the desolation, you sense order. Venus is stable in its chaos, trapped in an equilibrium so precise it's almost elegant. Its dense atmosphere creates a blanket that has stayed the same for millions of years. Storms form and fade, volcanoes exhale gases, but the temperature barely wavers. The planet has reached thermal stillness, the ultimate hot yoga pose. It's odd to think that just a few centuries ago people looked up at the bright evening star and pictured paradise. In 1761, the Russian polymath Mikhail Lomonosov watched Venus cross the sun and noticed a faint glow around the planet's edge. From that he deduced it had an atmosphere, an astonishing discovery at the time. He couldn't have known that the same atmosphere would one day destroy spacecraft faster than popcorn in oil. The irony is almost poetic. The capsule continues to fall, though the concept of down loses meaning when every direction feels like gravity's temper tantrum. The exterior sensors detect a subtle shimmer, heat gradients dancing like ghosts. The readings are off the charts. It's not just sunlight baking the air, it's the infrared glow of the ground itself radiating upward, trying and failing to escape. Venus doesn't release her heat. She hoards it like a dragon sitting on a treasure of pain. You can't help drawing comparisons to home. Earth's own greenhouse gases, carbon dioxide, methane, water vapour, work together to keep our planet habitable. But push the balance too far, and the spiral begins. Every fraction of a degree feeds the next. It's the same principle that turned Venus from a blue world into an amber inferno. Scientists use the phrase Venus syndrome as a shorthand for the ultimate climate catastrophe. No, we're not there, not even close, but Venus is the cautionary photograph pinned to the cosmic refrigerator. Don't overdo it. A flash of humour bubbles up in your mind. If Venus were a cooking show, she'd be that contestant who accidentally set the oven to molten core and then pretended it was intentional. The crust, overdone. The atmosphere, burnt to a crisp. Presentation, golden. Gordon Ramsay would be proud. As your capsule's descent slows, the pressure gauge stabilises. The numbers flicker and hold steady. For the first time since entering the atmosphere, you can breathe. Well, metaphorically. The air outside would kill you in less than a second. But the sense of equilibrium is soothing. You glance upward, trying to pierce the clouds. From here, the sun is nothing but a diffuse glow, like a lamp behind dirty glass. The thought crosses your mind. If Venus ever had a sky blue enough for birds, it's been gone for billions of years. The heat hums against the hull, a low metallic groan that vibrates through your seat. It feels alive, almost sentient, as if the planet is aware of your tiny intrusion and unimpressed. You record data, temperature profiles, gas composition, all the things scientists love, and yet the numbers feel inadequate. How do you quantify an atmosphere that's practically mythological? Somewhere far below, volcanic plains stretch endlessly, waiting for your next descent. They've baked under this same suffocating blanket for longer than mammals have existed on Earth. They're patient, you're not. Soon, you'll go lower. You'll see what the heat hides. For now, though, you linger in the mid-atmosphere, suspended between the world that could have been and the world that is. The realization settles over you like the planet's own pressure. Venus didn't just lose her oceans, she lost her second chance. You hover at the edge of the clouds where visibility drops to near zero and the air glows faintly orange, like the inside of a lantern. The atmosphere feels alive here, charged, restless, unpredictable. You can sense the voltage in it, like a static hum building just before a storm. Venus's sky is no quiet veil. It crackles with hidden tension. As your instruments reach deeper into the haze, the sensors start picking up sharp, irregular spikes. Electricity, lightning, or something pretending to be lightning. Scientists have been debating this for decades, and to be honest, even now nobody can say for sure what's happening up here. Some claim it's genuine thunderstorm activity, others that it's a weird chemical glow. Charged sulfur particles colliding in a dance of deceptive light. Historians still argue whether the earliest detections of Venusian lightning were real events or just the excited heartbeats of overly optimistic equipment. Your capsule shudders as a faint pulse passes through it, static electricity skipping across the hull. It doesn't feel violent, more like the soft tap of a cosmic fingertip. You glance at the readings again. The electric field is thousands of times stronger than Earth's average. The entire sky above is a cauldron of charged particles, grinding against each other in slow motion. There's a smell to it. Even through layers of filtration, the air carries a trace of burnt metal and sulfur, like fireworks in a chemistry lab. It's oddly nostalgic, if you've ever loved the scent of rain on hot asphalt. Only here, the rain would melt your skin. You try to imagine what a storm on Venus looks like. On Earth, lightning is bright and brief, cracking across a dark sky like a flashbulb. Here, the light diffuses through acid mist, turning into silent pulses that illuminate the clouds from within. The effect is eerie, like watching a heartbeat through translucent skin. Some early radar data from the Soviet Venera probes hinted at bursts of electromagnetic activity, but the signals were inconsistent, as though the planet itself couldn't decide whether it wanted to flash or smoulder. You drift a little lower, into a layer where the clouds thicken. Tiny droplets of sulfuric acid form and burst around you, creating a fine mist that coats the capsule's windows. Outside, those droplets constantly form and evaporate, sustained by a bizarre chemistry. Sulfur dioxide from volcanoes reacts with water vapor, what little is left, to produce sulfuric acid, which rains downward before evaporating again long before it ever reaches the ground. It's a cycle of false rain, a storm that never delivers, a promise broken again and again. Somewhere, a meteorologist's heart just cracked. A quick bit of trivia slips into your mind. NASA once nicknamed Venus's upper cloud layer the Cytherean Sea, after Cythera, one of the mythical birthplaces of the goddess Venus. They imagined their future airships floating through this ocean of mist, drifting peacefully like jellyfish. If they'd known how acidic and turbulent it really is, they might have picked a less romantic name. Something like the Big Yellow Nope. You tilt the camera downward. The brightness fades as you sink deeper. The clouds here are denser, their shapes sharper, more architectural. They rise and fall in slow-moving towers, tens of kilometers wide. At this level, winds can scream past at hundreds of kilometers per hour, part of a global jet stream that races around the planet once every 4 Earth days. It's called superrotation, and no one fully understands it. How can the atmosphere spin 60 times faster than the planet itself? Every simulation fails to explain it completely. Historians of science still argue whether the effect was first noticed by the Pioneer Venus mission, or earlier by Earth-based radar studies. But one thing is clear, Venus's winds don't follow rules, they make them. You catch a glimpse of something extraordinary. Tiny, ghost-like flashes dancing across the horizon. Ball lightning, plasma discharges. Nobody knows. They could be electrical arcs triggered by turbulence, or they could be illusions. Sunlight refracting through moving aerosol layers. Venus loves her mysteries and guards them well. One scientist once joked that every time we think we understand this planet, she laughs in sulfuric. The capsule vibrates again, more intensely this time. The sensors are going wild. Ion concentrations, electric potential differences, fluctuating magnetic fields. You realize you're inside a storm, though you can't see much beyond the glow. A faint rumble travels through the air. Not sound exactly, but pressure waves, felt more than heard. You lean against the window, watching as another pulse of light moves like a vein through the darkness. The clouds ripple with it. For a moment you could swear you see shapes, curves and tendrils, almost organic, as if the lightning were sketching nervous systems across the sky. Then it's gone, leaving behind a trembling silence. Venus's weather doesn't follow Earth's logic. It's not about moisture and cooling, it's about chemistry and violence. The very molecules here are restless, breaking apart and recombining endlessly under the weight of heat and radiation. Some scientists once proposed that the lightning might trigger chemical reactions capable of forming complex molecules, perhaps even precursors to life. The idea sounds hopeful until you remember that any organic compound here would last about as long as ice cream in a furnace. Still, hope is a stubborn thing, and speculation keeps the labs busy. You let the capsule drift laterally for a while, tracing the storm's outer edge. The density decreases slightly, and patches of translucent haze reveal glimpses of the layer below. It's darker down there, a brownish-grey soup of carbon dioxide and sulfur compounds. Somewhere within that murk, invisible to your eyes, are powerful updrafts dragging chemicals upward from the lower atmosphere, feeding the perpetual thunder you just witnessed. Venus, it seems, is powered by a churning engine of its own fumes. There's a kind of rhythm to it. The entire planet breathes, gases rising, condensing, breaking apart and sinking again. You start to feel it in your own chest, this slow in and out motion of atmospheric life. It's hypnotic, almost comforting, until you remember what those gases are. You chuckle quietly. It's the kind of laugh people make right before saying, "I've made a huge mistake." Yet even now, floating inside a storm of acid and fire, you can't help admiring it. The symmetry, the energy, the sheer scale of it. Venus doesn't whisper beauty, she shouts it through chaos. The lightning flares again, and for an instant the entire sky becomes molten gold. You realize you're witnessing one of the most violent displays in the solar system, and somehow it's mesmerizing. You press your hand to the cool interior glass, feeling the vibration fade. Somewhere beyond the haze, sunlight filters through in pale threads, as if the planet is teasing you with glimpses of day. It's never truly bright here, only degrees of dim. You check your altitude. Soon, you'll break through the lowest layer and approach the ground, where the real inferno begins. But for now, you hover between fury and silence, surrounded by lightning that may not even be lightning, beneath clouds that rain acid without touching Earth. Venus doesn't just burn, she dreams in gold and thunder. You sink through the final curtain of cloud, and for the first time since entering this golden labyrinth, you glimpse the surface of Venus. It's not what you expect. There are no flames, no flickering rivers of lava, just a dim, hazy glow that blankets everything in amber twilight. The ground stretches outward in blurred streaks, a heat-shimmered plain of cracked basalt and fractured stone. Even through the distortion, you can tell the land looks tired, like it's been baking under an eternal sun far too long. Every rock seems to sag slightly under its own exhaustion. The pressure outside your capsule is immense, enough to crush a submarine, and the temperature hovers near 465 degrees Celsius. Lead would melt into puddles here, and zinc would boil away entirely. It's a world where metals flow, where the definition of solid becomes negotiable. You remember the first images ever taken from this surface, those haunting snapshots from the Soviet Venera landers in the 1970s and 80s. The pictures came through distorted, sepia-toned, ghostly. Rocks littered a flat, dusty plain under a smoky sky. No horizon, no clouds, no sense of depth, just oppressive stillness. Venera 9 and 10 sent back panoramic photos before their lenses fogged and cracked. Venera 13, the most famous of them all, survived a heroic 127 minutes before the heat silenced it forever. In those last transmissions, you can see what looks like shattered paving stones, lava flows frozen mid-motion, and in one frame there's a metallic arm reaching down to scoop soil, like a human hand trembling in the furnace. You feel an odd pang of empathy for that machine, as if it knew it was witnessing something magnificent and fatal at once. The capsule touches down with a jolt that reverberates through your chest. The ground here is solid, but soft with dust. Dust made not of silica or sand, but microscopic glass beads, volcanic ash melted and resolidified countless times. It crunches beneath the capsule's landing struts, though the sound doesn't travel. The air is too thick. It muffles every vibration like a heavy blanket. Even if thunder rolled nearby, you'd only feel it as a slow, deep tremor in your bones. The light is strange, diffuse, directionless, as though the sky itself were glowing from within. There's no sunbeam, just a dull radiance filtering through sulfur clouds. If you could stand outside, your eyes would see only amber. Shadows blur. Everything looks slightly melted. The ground ripples with mirage waves, heat distortion dancing in lazy spirals. Your suit's sensors blink furiously, warning you that the external temperature exceeds all safety limits. You ignore the alerts. Curiosity has always been humanity's worst and best habit. Somewhere in the distance, jagged rocks rise from the plain, maybe volcanic outcrops, maybe just boulders warped by heat. The entire landscape is volcanic, born of molten fury. Venus has more volcanoes than any other planet in the solar system, over 1,600 identified, possibly millions if you count the smaller vents. Yet, strangely, none seem to erupt today. Scientists suspect the planet's entire surface was resurfaced hundreds of millions of years ago, when magma flooded nearly every valley and mountain, erasing its earlier history. It's as though the planet hit a cosmic reset button. Historians still argue whether this cataclysm was a single global meltdown or a long, slow process of renewal. Either way, Venus has no fossils, no sedimentary layers, no gentle record of time, just scorched memory written in basalt. A small tremor passes under you, barely a quiver, but enough to jostle a loose rock nearby. You wonder if Venus still rumbles with hidden life below its crust. The Magellan orbiter once mapped this surface with radar and found suspicious patterns, fresh lava flows, sharp ridges too crisp to be ancient. Some geologists believe volcanic activity still occurs here. Others dismiss it as wishful interpretation. But the idea lingers, stubborn and thrilling, that beneath this quiet inferno the planet still breathes. Your instruments begin to pick up faint magnetic variations, possibly from subsurface metal deposits. They hum softly, resonant through the hull. It reminds you of the sounds ships make when they glide through ice, low, singing groans that feel alive. You imagine the ground shifting in slow motion, pressure building in chambers deep below, molten rock pressing upward against the unyielding crust. The weight of that thought is almost unbearable. It's strange to think that this nightmare landscape may once have known rain, real rain, falling in soft silver drops across volcanic plains. Billions of years ago, before the greenhouse runaway, Venus might have had shallow seas and mild temperatures. If you'd stood here then, you might have seen water glinting under a pale blue sky. But the sun grew brighter, and the oceans began to steam. Water vapor, the most potent greenhouse gas, fed the warming until the last drop boiled away. The ultraviolet light from the sun split the escaping water molecules apart, hydrogen leaking into space while oxygen reacted with the rocks below. The seas vanished, the stones rusted. The air thickened, the pressure rose, and the surface became the furnace you see now. You glance at the temperature gauge again. It hasn't moved. 465 degrees Celsius, unwavering. Venus is a master of consistency. Even night brings no reprieve. The dense atmosphere spreads heat evenly across the planet. There are no cold poles, no cool mornings, only endless afternoon. The rotation of the planet is glacially slow, taking 243 Earth days to complete a single turn. In that time, the ground here has no sense of sunrise or sunset. It simply glows. A faint vibration hums through the structure again, and for a fleeting second, the ground beneath the capsule shifts by a fraction of a millimeter. It's probably thermal expansion, but you prefer the fantasy that something deep below just sighed. The sound, if you could hear it, would be the whisper of magma pressing its hand against ancient rock. You check your cameras, they're fogging at the edges, just like Venera's did. The internal cooling system struggles to compensate, but the planet always wins. Venus doesn't destroy quickly, she erodes patience. The glass warps, the instruments flicker, and a faint hiss fills the cabin as the atmosphere outside gnaws at the seals. You realize that in this moment, you're sitting on a surface that no human has truly seen with their own eyes. Every image we've ever received was filtered, colored, interpreted. The real Venus might not even look like these amber tones we assign to her. She could be dull grey or copper red or something our vision can't define. It's humbling to think that even now, with all our technology, the world beneath your capsule remains half imaginary. There's a certain serenity to it, though. The endless heat, the silence, the stillness. It feels almost meditative, in a horrifying way. You think of the old philosophers who named the planet for the goddess of beauty and love. If only they could see her now, a goddess wrapped in flame, still radiant, still captivating, but utterly untouchable. You can't help but smile. Beauty, it turns out, can survive even in hell. You move across the surface, the capsule crawling like a cautious beetle through the haze. Navigation here is a guessing game. Radar maps provide outlines, but the ground shifts subtly, reshaped by unseen forces. Before you stretches a vast plain of volcanic rock, smoother than expected, broken only by scattered dome-shaped mounds. These are not hills in any ordinary sense. They rise gently, each about a kilometre wide and only a few hundred metres tall, resembling stacks of pancakes poured too thick. Planetary geologists, because space detectives apparently wasn't an available job title, call them pancake domes. Their formation remains one of Venus's ongoing riddles. Some think they were created by slow eruptions of thick, sticky lava, the kind rich in silica. Others argue the lava was thinner but solidified too quickly under the immense pressure. Historians still argue whether the domes mark ancient volcanic vents or the final size of a dying mantle. You guide the capsule toward one, the radar echoing in rhythmic pulses as it scans ahead. The slope is shallow but deceptive. Beneath that crusty veneer lies molten memory. The heat beneath your feet is unbearable, even through layers of shielding. Venus radiates not just from above, but from within. The planet doesn't just have volcanoes, it is one. Over 80% of the surface is volcanic plains, rivers of frozen basalt that once flowed like water. Imagine the Sahara, but instead of dunes, every grain is a cooled lava ripple. You spot one of the great ridged structures that define this world, a corona. Not the solar kind that dazzles during an eclipse, but a planetary scar. Vast circular patterns formed when hot magma pushes upward, bulging the crust before collapsing inward again. Some coronas stretch for hundreds of kilometres, complex as fingerprints. You circle one now, the radar mapping its concentric rings. It looks eerily organic, like the imprint of a giant fossilised cell. Scientists once speculated these might be failed continents, or even evidence of plate tectonics. But Venus doesn't play by Earth's rules. There are no plates sliding or colliding here, just one continuous shell cracking occasionally to vent her fury. A quick pulse of motion outside catches your eye. Dust, or what passes for it, whirls briefly before settling again. It's not wind exactly. The atmosphere is too dense for dramatic gusts at this altitude. Instead, convection currents shift the air in slow, syrupy eddies. The dust glows faintly in the perpetual amber light, like golden snowflakes that forgot how to fall. You're reminded of early radar scans from the Magellan orbiter in the 1990s, when it revealed Venus's surface in astonishing detail. Before Magellan, scientists thought the planet might be covered in smooth plains. The data instead showed mountains, volcanoes and rifts stretching thousands of kilometres. Magellan mapped 98% of the planet, an act of cosmic cartography done entirely through clouds. The capsule glides over the plain, passing clusters of fractured ridges and collapsed lava tubes. You imagine what it might feel like to walk here. If your boots didn't vaporize instantly, the ground would be slick, uneven, and treacherous. Some regions might still be warm enough to glow faintly at the edges. Venus doesn't have liquid water, but it does have a kind of flow, lava channels that once carried molten rivers for hundreds of kilometers. You see one of these now, a dark groove winding across the plain like a scar carved by time itself. Some of these channels are longer than the Nile River. Scientists call them canali, and they are among the strangest formations in the solar system. There's something eerily familiar about it all, though. Strip away the heat, the acid, and the pressure, and what remains could almost be an earthly landscape, a volcanic desert, silent and desolate. You think of Hawaii's black basalt fields or Iceland's lava plains. The same physics, different settings. The universe, it seems, recycles beauty. A curious thing about these volcanic structures, they may not be ancient. Some radar studies suggest fresh lava flows no older than a few years, or perhaps even months. Thermal imaging from orbit once detected slightly warmer patches, implying that eruptions may still occur sporadically. Historians still debate whether Venus is geologically active today, or merely experiencing posthumous twitching. But if she is alive, those pancake domes and canali might be her slow, simmering heartbeat. You steer toward the horizon, where the terrain rises into jagged mountains, Aphrodite Terra, one of Venus's massive highland regions. From a distance, the mountains blur into smudges against the thick air. They're ancient, formed by immense compressional forces rather than plate collisions. The crust here has buckled and folded like soft dough, frozen mid-need. Some slopes may reach heights comparable to Mount Everest, though climbing them would be the world's least advisable vacation plan. The capsule's cooling system hums louder, struggling. The exterior panels read over 500 degrees Celsius, well past safe operational limits. You decide to linger only a little longer. The sight of this scorched geology deserves every second of risk. You extend a robotic arm to collect samples, tiny scoops of rock that will never make it home, but their data will. The sensor returns surprising results. Basalt, yes, but also traces of minerals that may have formed in the presence of water long ago. It's like finding an old letter sealed in stone, written by a planet that forgot how to speak. There's a faint vibration again, a low rumble that feels deeper than sound. The capsule's instruments twitch, pressure fluctuations, maybe seismic. You hold your breath, waiting. Then it comes, a subtle, rising tone, a tremor through the crust that fades almost as soon as it begins. Could it be an eruption? Maybe just the shifting of ancient faults under impossible stress. Venus is quiet, but not still. She sighs occasionally, just to remind you she's awake. A stray thought crosses your mind. If humans ever found a way to stand here, what would they say? Would they marvel at the colour, the silence, the beauty? Or would they collapse under the crushing heat and call it madness? You imagine explorers in reinforced suits trudging across glowing stone, their helmets reflecting the dull gold sky. They wouldn't hear birds, wind or water, only the low hum of their own machinery and the heartbeat of their courage. It's almost poetic, this paradox. Venus, the goddess of love, turned into a monument to endurance. Her surface tells the story of creation and destruction in the same breath. Every dome, every fissure, every melted stone is a fossil of fury. And yet, as your capsule begins to rise slowly back toward the upper haze, you find yourself reluctant to leave. The inferno has a strange allure. It's the beauty of resilience, of a world that refuses to cool, to die, to fade. You glance one last time at the landscape below. The mountains blur into amber mist. The plains dissolve into heat shimmer, and the light grows softer, almost tender. Venus doesn't wave goodbye. She simply continues, unbothered, unchanging. Somewhere below, the lava still sleeps, waiting for its cue to flow again. You smile faintly. Every planet has its heartbeat. You've just felt Venus's. As the capsule rises, the landscape below fades into a golden blur, and for a moment you can almost pretend it's dawn on some tropical shore. Almost. But that warmth you feel isn't sunlight. It's the ghost of oceans that once were. You adjust the instruments, watching as the spectrometer reads faint traces of deuterium, heavy hydrogen left behind when lighter atoms of water floated away into space. It's the planet's confession, written in isotopes. Once, Venus may have glittered with shallow seas, clouds made of gentle rain, and waves that whispered against volcanic shores. That version of her is long gone, boiled dry by a star that grew a little too bright in an atmosphere that forgot moderation. You try to imagine it, ancient Venus with a sky of soft blue instead of sulfur yellow. The temperature comfortable, the air thick but breathable, the sun a little larger in the sky but not yet cruel. Scientists at NASA once ran climate simulations suggesting that for nearly 2 billion years, Venus could have supported liquid water. Imagine rivers carving through basalt plains, steam rising from rain on fresh lava. Maybe it even had something resembling continents, patches of high ground where storms gathered. Then, the spiral began. The oceans evaporated. The water vapor trapped more heat. The carbon dioxide built up, and the planet crossed a threshold it could never return from. Historians still argue whether the oceans were deep and global, or just vast shallow seas, the kind you could wade through forever without finding an edge. Some fringe researchers even speculate that primitive life might have emerged there before everything boiled away. They picture simple microbes floating in those early waters, evolving for millions of years before being erased without a trace. It's a comforting thought, or maybe a tragic one, that life might have once existed so close to Earth, only to be snuffed out by its own sunlit cradle. You recall a curious discovery from a Japanese mission called Akatsuki, which still orbits Venus today. It detected patterns in the clouds, long wave-like streaks stretching across the entire planet, hinting at interactions between atmosphere and surface. Some scientists think these waves are echoes of the long-dead ocean floor, faint topographical memories influencing the air above. If true, then even now, the vanished seas still speak, their ripples fossilized into the planet's breath. The capsule drifts into calmer air, where the visibility improves slightly. The sky is the colour of burnished copper. You can almost feel the temperature difference. Here it's a balmy 200 degrees Celsius, cold enough that your instruments sigh with relief. The thought of cold being anything over boiling feels absurd, but on Venus, absurdity is the baseline. The upper haze layers roll like slow tides, heavy with sulfuric acid droplets. Your filters catch the faint shimmer of sunlight filtering through, an echo of what those lost oceans might have reflected billions of years ago. For a moment you close your eyes and listen to the faint hum of the machinery. The sound merges with your imagination, the whisper of ancient waves, the hiss of rain that hasn't fallen in eons. You can almost see it, the surface wet and dark, steam rising from warm seas under a soft golden sky. Maybe it looked like Earth's early days, before continents grew proud and life began to decorate them. Some researchers once proposed that Venus could have been habitable up until 700 million years ago, meaning that while dinosaurs roamed Earth, Venus was already dead. Two worlds, born together, diverging in silence. There's something inherently heartbreaking about that image. You can't help but wonder, if intelligent life had ever evolved there, would they have watched the oceans vanish? Would they have built myths about the growing heat, the sky turning opaque, the last drops of rain sizzling on black rock? It's probably nonsense. Venus's window for life was likely too brief for intelligence, but the idea lingers anyway. Humanity's imagination thrives where evidence is scarce. A flicker of humour passes through your thoughts. If Venus once had beach vacations, the sunscreen would have been made of liquid metal and regret. You picture ancient Venusian travel brochures. Visit scenic Lava Bay. Temperatures only mildly apocalyptic. You laugh softly, though the sound is swallowed by static. Humour helps. It's the only way to face a planet that defies logic and comfort at every turn. As you rise higher, the instruments begin to detect the chemical signatures of sulfur dioxide and carbon monoxide mingling in dense layers. These gases once played a key role in the planet's long transformation. When water vanished, volcanic outgassing continued, pumping sulfur compounds into the sky. Without rainfall to wash them away, they lingered, reacting and building up until the clouds became toxic oceans of acid. The process sealed Venus's fate, a feedback loop that trapped every calorie of solar energy and smothered any hope of recovery. Still, the mystery deepens. Why did Venus lose her water while Earth kept hers? The planets are nearly the same size and composition. Their births were twin stories from the same cosmic nursery. Some scientists point to Venus's lack of a magnetic field. Without that invisible shield, solar winds stripped away the hydrogen from water molecules, leaving oxygen to rust the rocks. Others argue that Venus's slower rotation doomed her. Without the cooling cycles of day and night, her early oceans evaporated faster. Historians of science still debate which of these theories holds the truth, though they all end with the same moral. The universe plays favourites, and Earth got lucky. The capsule stabilises in a layer of atmosphere where pressure matches what you'd feel at sea level back home. It's a strange twist. At this altitude, about 50 kilometres above the surface, the temperature and pressure are actually Earth-like. If not for the acid, you could almost breathe here. Some dreamers have proposed floating cities that could drift at this height, vast airships powered by solar energy, cruising perpetually through the golden clouds. It's the kind of idea that feels halfway between genius and science fiction. You smile at the thought. Humanity always looks for a way to turn even hell into a vacation spot. But as you hover in this calm, acid-scented peace, you can't escape the melancholy of what's gone. The oceans that might have shimmered here are now only isotopic ghosts. The clouds that once carried rain now carry corrosion. The air itself hums with the memory of evaporation. Venus didn't die suddenly. It was a slow unravelling, a planetary heartbreak stretched across eons. You glance down one last time toward the shimmering blur below. In that diffuse glow, you can almost trick yourself into seeing waves again. It's a mirage, of course, a thermal illusion. But imagination fills the gaps where data ends. For a heartbeat, you let yourself believe you're watching sunlight dance on an ancient sea. The sight is beautiful, unbearable, and gone in an instant. You're hovering now where the heat softens from inferno to furnace glow, roughly 55 kilometers above the ground, an altitude that could almost be kind. The air pressure here is close to what your body knows from home, and for the first time since entering this world, you can imagine surviving outside the capsule. You'd still need armor against acid and heat, of course, but if humanity ever lives on Venus, this is where we'll drift. You're inside the zone of the whispering winds, where the atmosphere howls around the planet with impossible speed. It's like standing in the eye of an invisible hurricane that never stops spinning. You glance at the data stream and shake your head. The winds here can reach 360 kilometers per hour, hurricane strength, and yet the entire atmosphere completes a full rotation of the planet in just 4 Earth days. Venus itself turns so slowly that its day is longer than its year, but the air above refuses to wait. It races around the globe, dragging clouds with it, a phenomenon called superrotation. Historians still argue whether we first confirmed it from the Japanese Akatsuki orbiter or earlier radar readings, but everyone agrees it's one of the strangest dynamics in the solar system. You tilt the capsule and let the wind catch your stabilizers. The whole craft quivers, not violently, but with steady insistence, as if the air wants to carry you somewhere. Through the thick windows, the clouds streak by in horizontal lines of pale amber and grey. They look like brushed metal polished by motion. There's no sound. Venus's atmosphere is too dense to convey a familiar whistle, but the sensors vibrate with the low frequencies, a bass hum that you feel in your bones. If you step back from the instruments and just let your eyes wander, you notice subtle waves moving through the mist. These are gravity waves, not the space-time kind, but the atmospheric cousins, ripples of pressure born when air flows over mountains far below. Venus's wind is so fast that it smears these waves across continents. Some are visible even from orbit, curling like scars across the planet's face. You remember the massive bow-shaped wave Akatsuki photographed stretching 10,000 kilometers long over Aphrodite Terra. It's as if the planet wears the memory of its mountains in the clouds above them. You extend a probe through the hatch to sample the air. Sulfur dioxide dominates, but there are hints of other molecules, carbonyl sulfide, water vapor, even traces of chlorine compounds. The acid mist etches the probe's surface almost instantly, leaving microscopic pits that sparkle under the capsule's lights. It's beautiful in a self-destructive way, like snow made of venom. The sample readings dance across the monitor, the numbers barely stable. You can't help smiling. This is how scientists flirt, with data that threatens to dissolve them. A stray thought crosses your mind. If someone could stand on the exterior hull and stretch out their hand, they'd feel wind like silk mixed with sandpaper. It would push, not buffet, and you'd drift instead of sway. Because of the high density, the air has weight. Every gust carries momentum, a reminder that this isn't just atmosphere, it's a slow ocean of gas. The entire planet is wrapped in a fluid that behaves somewhere between air and liquid. You imagine what these winds would look like from orbit. They'd appear serene, slow-moving swirls, but from here they are a rushing torrent. The upper cloud tops move in elegant patterns of cream and gold, but beneath them, hidden layers churn violently, where turbulence shreds structure and reforms it again. It's planetary choreography, graceful from a distance, chaotic up close. There's an open scholarly debate about what drives the superrotation. One camp says it's the sun's heating of the upper atmosphere, creating a massive heat engine. Another suggests wave interactions and the planet's strange Coriolis effect conspire to accelerate the air. A few propose deeper mysteries, unknown chemical processes or internal heat currents, coupling surface and sky. No model explains it perfectly. You could say Venus keeps her meteorology as close as her secrets. The capsule drifts with the current, gaining speed. The pressure gauge drops slightly as you rise another kilometre, and for a fleeting second you see a lighter layer of haze where the sun's glow tries to break through. It's not bright, but enough to cast faint shadows inside the cabin. You raise your gloved hand to the glass, tracing the faint line of light. It's the first sunlight you've seen since entering the atmosphere. You savour it the way sailors once did after months at sea. At this altitude, temperatures hover around 75 degrees Celsius, dangerous but survivable with proper shielding. It's a curious balance. The upper clouds are too thin for floating platforms, the lower air too dense for safety. But here, between them, lies a zone of promise. NASA engineers call it the habitable deck, a layer where future explorers could build habitats suspended by helium and breathable air. Since carbon dioxide is heavier than nitrogen-oxygen mixtures, our own air could serve as flotation gas. Human cities could literally float on their own breath. It's a notion so absurdly poetic that it might actually work someday. You picture it, vast silver blimps drifting through honey-coloured skies, solar panels glittering, observation domes facing downward toward the planet's endless glow. From those vantage points, the inhabitants would see an unbroken sea of clouds. No horizon, just luminous amber stretching forever. It would be beautiful and terrifying, like living inside the heart of a candle. A flicker of movement outside catches your attention. Tiny, transient sparks darting across the mist. They're not lightning this time, but charged dust or microplasma events created by friction in the high winds. The sensors pick them up as soft blips of static. It feels like the planet whispering. Maybe that's why people call this layer the whispering winds. Every shift in temperature, every eddy, carries a murmur that no one can quite translate. You record the data and let the capsule continue its drift. The rhythmic hum of the wind becomes hypnotic. You think about the fact that Venus spins backward compared to most planets. Its rotation is retrograde, so the sun appears to rise in the west and set in the east. Yet the winds ignore this rebellion, flowing eastward anyway, faster than the planet can turn. It's as though the atmosphere refuses to follow Venus's example, declaring, "You may crawl, but we'll fly." A soft laugh escapes you. Even planets have personality quirks, and Venus's is contradiction. She's a slow dancer wrapped in a storm, serene from afar, ferocious up close. The wind continues to push, and the capsule glides effortlessly through invisible rivers of air. The motion feels almost organic, like drifting through a bloodstream. For a fleeting moment, you feel weightless, peaceful, a guest inside a living system too vast to comprehend. You check the compass. Utterly useless here. Every direction is east because the air itself is east. You could spin forever and never change course, so you stop fighting it. You lean back, listen to the soft static of your instruments, and let the whispering winds carry you where they will. Above, faint sunlight glows like a halo. Below, acid clouds boil in gold. And somewhere in between, you float in the only place on Venus where peace can survive. You've been drifting for hours now, carried by the whispering winds until the air grows heavier again. Slowly the capsule descends into a darker realm, where the clouds thicken into towering masses and the horizon disappears. The light fades to bronze and then to something close to sepia, as though the whole world has been dipped in rust. You angle the radar downward to glimpse the surface again, but this time you're not searching for volcanoes or plains, you're looking for tesserae. The word itself feels elegant, like the name of a forgotten goddess, but it describes some of the most chaotic terrain in the solar system. Venus's tesserae are vast, ridged highlands, old, folded crust that defies interpretation. Through the haze you catch radar reflections, patches of high reflectivity that gleam faintly in false colour. They rise like continents out of the lower plains, their shapes tangled, cross-hatched, broken. Each ridge intersects another at impossible angles, forming a surface that looks less like geology and more like the topography of madness. Historians still argue whether these tesserae are the last surviving fragments of ancient continents or the wreckage of colossal impacts. Some scientists think they represent Venus's original crust, preserved before the planet resurfaced itself in molten rage. Others believe they're younger, sculpted by internal stress and volcanic deformation. The debates have lasted decades, and somehow, the mystery only grows richer the longer we look. You tilt the capsule's sensors to scan one of these regions, Fortuna Tessera, one of the largest, covering an area bigger than Australia. The radar image paints the landscape in shades of amber and gold, like crumpled foil reflecting hidden firelight. You can almost feel the texture of it: jagged ridges, steep valleys, and flat-topped plateaus warped by time. The tesserae have endured where younger plains melted away. They are the planet's memory, geological fossils of a time before the Great Resurfacing event. Every ridge is a page in Venus's stone diary, but the language remains untranslated. It's impossible not to imagine what this world looked like when those formations rose. Maybe the crust buckled slowly under unimaginable pressure, like the skin of bread baking too long. Or maybe entire regions convulsed at once, their surfaces lifting, folding, and freezing within days. The heat here doesn't just sculpt, it scalds entire epochs into a single layer. You wonder if the tesserae hold trapped minerals from ancient oceans, silicates or clays that once interacted with water. If someone ever digs there, maybe they'll find the fingerprints of a world that once flirted with life. A curious piece of trivia floats up from your memory. When the Magellan spacecraft first mapped the tesserae, the images were so complex that early researchers thought the data might be corrupted. The patterns were too intricate, the ridges too irregular. Only after multiple passes confirmed the readings did they accept the truth. Venus had landscapes unlike anything else in the solar system. The planet wasn't chaotic, it was artistic. Every wrinkle, every fold, every fracture was part of a pattern so large the human brain struggles to parse it. You descend slightly to get a better view, and the instruments immediately protest. The pressure climbs rapidly, the temperature spikes again. You're brushing the ceiling of the inferno once more, but the temptation to linger outweighs caution. Through the haze, the radar's topographical renderings show labyrinthine canyons, some wide enough to swallow entire mountain ranges from Earth. The tesserae look alive, writhing in slow motion, though you know it's just illusion. Still, you half expect the ground to move. Scholars have a running joke. If you think you understand tesserae, you don't understand Venus. Even the simplest theories contradict themselves. Were these ridges formed by compression or extension? Did they rise from volcanism or sink under their own weight? Each explanation unravels under new data. One hypothesis suggests that tesserae mark zones where Venus once had prototectonic plates, tiny crustal fragments drifting and colliding before the planet froze into a single slab. If that's true, Venus once mimicked Earth's plate tectonics, perhaps even had continents and subduction zones, before something catastrophic ended it. That something, of course, remains a mystery. The capsule glides along the upper boundary of the tesserae region, buffeted by turbulence. The wind at this altitude is uneven, curling around the highlands in vortices that mimic mountain waves on Earth. These eddies stir up localized storms, miniature cyclones spinning in slow ballet. The clouds around you twist and shimmer, their outlines glowing faintly with reflected heat from below. It's almost hypnotic, a slow-motion light show performed in golden grey. You extend the radar arm again and collect data from the reflected echoes. The readings suggest that the tesserae have higher radar brightness than the surrounding plains, which could mean they're coated with metallic frost, perhaps pyrite or tellurium compounds condensed from the superheated atmosphere. Imagine that, a landscape shimmering with microscopic crystals, a world literally dusted with metal. Even hell, it seems, can't resist a little sparkle. The thought of metallic frost makes you laugh quietly, and you picture an alternate reality where Venus hosts luxury spas offering sulfur exfoliation and gold dust facials. If someone could bottle this planet, it would sell under names like Eau de Catastrophe or Essence of Doom. The humour fades quickly, though, replaced by awe, because behind the joke lies a strange beauty. Venus, even at her harshest, insists on radiance. Your instruments begin to stutter, interference from the electric fields that dance above the tesserae. Static fills the audio feed, a faint crackling that sounds eerily like whispers. It's not speech, of course, but it feels intimate, as if the planet is murmuring its own history in a frequency humans can't quite translate. You catch yourself whispering back, telling it you're listening. Maybe that's what exploration is at its core, a quiet conversation with things older and larger than ourselves. There's one last fact you recall before pulling up. Some radar imagery hints that tesserae regions might be slightly younger than the plains around them. If true, they could be the latest scars rather than the oldest bones, a reversal that would rewrite the story of Venus's evolution yet again. Historians of science still debate the data, their arguments looping in circles like the winds here. You smile at the irony. On Venus, even time seems to fold in on itself. The capsule begins its ascent, climbing back toward the gentler layers of air. Below, the tesserae vanish under their sulfur veil, their mysteries intact. You watch until the last glimmer fades into cloud. The golden fog thickens again, swallowing everything, including your certainty. Venus never gives answers, only invitations to wonder, and as the radar beam shuts off, you realise that's enough. Wonder, after all, is the most durable thing in the universe. You climb higher, the tesserae shrinking below until they're little more than faint radar ghosts. The atmosphere grows slightly clearer, the light softer. You hover here, in the mid-layer haze, adjusting your instruments to peer once again through the murk, not for mountains this time, but for motion. Somewhere below, Venus might still be breathing fire. It's hard to believe, given how still the planet seems, but some data refuse to stay silent. You've heard the rumours, the subtle changes in thermal readings, the infrared flickers seen by orbiters, the hints that maybe, just maybe, Venus's volcanoes still breathe. You stabilise the capsule and deploy a thermal sensor suite, tuning it to detect even faint heat variations from the surface below. Almost instantly, the readings waver. A region near Mat Mons, the tallest volcano on Venus, shows irregular heat signatures, the kind that could mean anything: instrument noise, hot rock, or something alive in geological terms. You zoom in. The pattern flickers, vanishes, returns stronger. It feels like a pulse, not random, not steady, but real. Back on Earth, scientists once studied these same fluctuations using radar data from the Magellan orbiter and found subtle changes in reflectivity over time. At first, they thought it was error. Later, they wondered if it might be fresh lava cooling on the surface. In 2023, a team compared Magellan images taken months apart and found evidence, clear as fingerprints, of a vent that had changed shape. The first confirmed sign of an active volcano on Venus. It was a quiet revolution, rewriting what we thought we knew about this world. Venus wasn't just a fossil, it was alive, smouldering beneath its acid breath. Historians still argue whether that discovery means widespread volcanism or isolated activity. Maybe only a few vents still exhale. Maybe the planet simmers everywhere, hiding eruptions beneath her perpetual cloud cover. Either way, the implications are staggering. Active volcanism means internal heat, convection, maybe even tectonic stirrings. It means the heart of Venus is still beating. You look down now and imagine that warmth spreading upward, curling through layers of rock like the breath of something sleeping but not dead. The capsule's sensors vibrate faintly as you adjust course toward a region known as Ganiki Chasma, a fracture zone that some think could host modern eruptions. The radar beam paints it in shades of grey, a long gash slicing through the crust like a scar. Around it, the plains shimmer with unusually bright returns, perhaps cooled lava flows, perhaps illusions of the atmosphere. You zoom closer and see subtle textural differences, smooth patches where lava might have recently spilled, ridged edges where it crusted as it cooled. The shapes are hauntingly familiar, like aerial photos of Iceland's lava fields. Except here, each ripple could stay molten for months. The thought hits you, if Venus still erupts, it's doing so in total silence. The air is too dense for shockwaves, too thick for flames to dance. Eruptions here would be slow, muffled exhalations, fountains of molten rock pushing through air heavy enough to smother fire itself. The lava would glow faintly orange against the perpetual gloom, illuminating nothing but its own shimmering surface. You can almost picture it, a planet crying in slow motion, her tears made of magma. A quirky tidbit slips into your mind. During one of the Soviet Venera missions, instruments detected a strange spike in acoustic pressure, a faint rumbling that some researchers later suggested could have been an earthquake, or perhaps volcanic activity. Of course, it could also have been the lander's dying gasp before its hull gave way, but the coincidence keeps the mystery alive. Historians still debate whether the Soviets heard Venus's voice before the heat silenced it forever. You descend slightly to test the air chemistry again. The gas analyzer detects sulfur dioxide concentrations that fluctuate more than expected. On Earth, such spikes are often volcanic fingerprints. Maybe it's coincidence, maybe it's a clue. Venus's clouds are full of sulfur, but variations in density could indicate fresh emissions from below. You grin. The planet may be trying to tell you something, and it's doing it in the only language it knows, chemistry. The capsule edges along the edge of the radar zone, scanning. Every so often, the instruments pick up faint infrared flares, nothing steady, just brief, whisper-like warmth. They fade as quickly as they appear, but each one sets your heart racing. If you could descend again, right to the surface, Maybe you'd find lava flow still cooling, maybe even see a red glow piercing the haze. But the risk is too high. You'd melt before you could confirm it. Still, the thought refuses to leave. You realise you're smiling again, a tired, awed smile, the kind only a scientist wears when the universe teases them with partial answers. You glance at the navigation console, which now overlays topographic data with historical imagery. The volcanoes stretch in endless chains, hundreds of them, each a silent monument to the planet's restless past. Mount Mons, Sapus Mons, Thea Mons, names borrowed from myth because only myth feels appropriate for a world like this. The highest peaks here rise higher than Mount Everest, but are weighed down by air thicker than water. Lava would ooze rather than explode, and ash clouds would hang motionless in the suffocating sky. You picture it and realise, this is what geological eternity looks like. It's humbling, this realisation that a planet can die and still breathe, that beneath the stillness, heat waits patiently, pressing against the crust like a heartbeat against ribs. You think of Earth's own volcanoes, Kilauea, Etna, Stromboli, all of them pulsing with life, reshaping continents grain by grain. Venus is doing the same, just more quietly, more desperately, perhaps without end. A flicker of static cuts through your thoughts. The instruments jitter, spikes of magnetic interference from below. You tap the console, watching as the readings level out again. Maybe it's nothing, maybe it's everything. You lean back and close your eyes for a moment, listening to the faint hum of the capsule. The air outside is boiling, the surface beneath is molten, and yet there's peace in the thought that the planet refuses to be still. You remember something an astronomer once said, Venus is not dead, she's just sleeping under a fever. It feels true now. The warmth you detect isn't just temperature, it's defiance. A planet's refusal to cool, to surrender, to let silence claim her. You take one last scan before pulling up, capturing a final set of data from the glowing veins below. They pulse faintly on your monitor, like embers buried in ash. As you ascend again toward the golden clouds, you look back one more time. The light from below is faint, filtered through kilometers of carbon dioxide, but it's there, an orange heartbeat, steady and stubborn. You whisper, half to yourself, half to her, "Keep burning." Venus answers the only way she can, with silence hot enough to melt stone. You drift upward again, leaving the warmth of the volcanic plains behind, back into the middle atmosphere where the clouds curl like torn silk. The air grows paler here, tinted the colour of old ivory, and somewhere within that pale haze lies one of Venus's strangest mysteries, the phosphine puzzle. It begins, as most cosmic controversies do, with a telescope pointed at something that should have been impossible. You stabilise the capsule and check your external spectrometer. It's tuned to pick up trace gases, and tonight, if night even means anything here, you're chasing the faint signature that shook planetary science in 2020. A group of astronomers using the James Clerk Maxwell Telescope and the ALMA array claim to have detected phosphine gas in Venus's atmosphere. On Earth, phosphine is associated with biology, produced by bacteria in oxygen-free environments like swamps and decaying matter. In the lab, it can be manufactured industrially, but on a planet like Venus, there should be no easy way to make it. Too hot, too dry, too oxidizing. And yet, there it was, a spectral line that whispered, something strange is happening up here. Historians still argue whether it was real. Within months, other teams reanalyzed the data and said the signal might have been a processing artifact or sulfur dioxide pretending to be phosphine. The debate became a scientific soap opera, papers refuting papers, telescopes repointed, data re-reduced. One researcher compared it to finding perfume on the battlefield. The evidence came and went, flickering like static. Some claimed the signal varied with altitude, stronger in the clouds where temperatures are mildest, around 30 degrees Celsius, the same range where microbes could theoretically survive if shielded from acid. Others found nothing at all. The universe, it seemed, had once again given us a maybe. You adjust your spectrometer and for a moment the screen flickers. There, a small dip in the expected continuum. Your heart jumps even though you know it's probably noise. The planet teases you the way it teased them. You increase sensitivity, filter background radiation, cross-check with sulfur dioxide lines. The dip remains, not deep enough to claim discovery, but enough to taste wonder. You grin despite yourself. Science is 90% heartbreak, 10% adrenaline. Outside, the clouds thicken into slow whirlpools, glimmering faintly with backscattered sunlight. You imagine what it would be like to float here in person, suit reinforced against acid, goggles fogging as you look around at this sepia sea. Somewhere in this layer, 50 kilometers above the surface, conditions hover near earthly comfort. Pressure similar to home, temperature bearable. It's here that dreamers imagine life might cling to existence, not on the ground, but in the sky. It's not as absurd as it sounds. On Earth, microbial life thrives in airborne droplets, surviving radiation and desiccation while riding thermals for weeks. If similar organisms evolved on Venus back when she still had oceans, perhaps they adapted upward as the planet grew hotter, retreating to the clouds, aerial plankton of another world. Historians of science still debate whether Carl Sagan's 1967 paper proposing Venusian cloud life was visionary or whimsical, but it remains one of the boldest ideas ever printed under peer review. You picture them, tiny acid-proof cells drifting in the golden fog, feeding on sunlight or sulfur compounds, clustering in droplets that rise and fall like living balloons. The chemistry is brutal. 98% sulfuric acid, minimal water, little nitrogen. But then again, extremophils on Earth make a living in boiling vents and nuclear reactors. Life's resume is impressive. Maybe in some microscopic way, Venus never stopped being alive. Your instruments pick up faint organic fragments, carbon, hydrogen and oxygen lines, but nothing conclusive. Still, for a moment you let yourself imagine that you've found evidence, that right now your capsule is brushing through invisible colonies of life older than humanity itself. You laugh quietly. It's not the confident laugh of discovery, but the nervous one of someone flirting with impossibility. You lean toward the window. The clouds outside swirl like a living organism, and the light within them pulses faintly as sulfuric droplets scatter the sun's last photons. It's easy to see faces in them, shapes that look like wings, spines, or filaments. Pareidolia, of course, but your imagination doesn't care. It sketches what data can't prove. You think of all the missions that have passed through here. Pioneer Venus, Vega, Akatsuki, all capturing glimpses but never certainty. The more we study Venus, the more she hides. The spectrometer beeps again, another dip. You log it automatically, but your mind is elsewhere, wandering through the possibilities. If the phosphine is real and not biological, what else could create it? Volcanism could, under rare conditions. Lightning, perhaps, though most models say no. Some suggest ultraviolet light might catalyze reactions in the upper atmosphere that mimic life's handiwork. Chemistry masquerading as biology. It would be the most Venusian trick imaginable. You recall a fringe proposal that still circulates at conferences, that Venus's atmosphere undergoes a dark photochemistry, reactions powered by infrared rather than visible light, producing exotic molecules we barely understand. The idea sounds absurd, but then again, so did a runaway greenhouse until we found it burning quietly next door. A joke comes to mind, one of those weary quips scientists tell to cope. If you find phosphine on Mars, it's life. On Venus, it's chemistry. On Earth, it's politics. You chuckle into the recorder. The static almost sounds like someone laughing back. The clouds around you pulse again, as if the planet is breathing. You remember that Venus reflects more sunlight than any other planet. Her albedo so high that from space she shines like a mirror. But that brilliance hides this darkness, this mystery of invisible gases that might mean everything or nothing. You wonder if she enjoys the irony, the brightest planet keeping the most secret. Your instruments begin to heat, the spectrometer nearing its limit. The signal fades, and with it your fragile sense of revelation. Still, you record the data, tagging it with notes and coordinates. Someday another probe might pass this same region and find more. That's the rhythm of exploration. Each discovery half finished, waiting for someone else to finish the sentence. You take one last look out the window before retracting the instruments. The haze glows softly, like a candle seen through milk. You imagine microscopic creatures drifting out there, luminous in the gloom, ignoring your presence completely. Whether real or fantasy, they make the air feel less empty. The capsule ascends slowly, its engines humming like a lullaby. The phosphine puzzle remains unsolved, hanging between chemistry and life, skepticism and wonder. You glance at the data screen again, the faint dip still visible like a heartbeat. You whisper, "Maybe someday we'll know." Venus doesn't answer. She only breathes acid and light and keeps her secrets another day. The haze parts above you faintly, revealing something Venus almost never shows: structure, order, and a hint of geometry beneath the chaos. From this altitude, you can see patterns forming in the clouds, great sweeping bands that curl like ribbons around the planet's waist. For the first time in hours, sunlight feels present rather than imagined, diffused into a pale amber wash that glows against the capsule's hull. You steady your hands on the controls, recalibrating the radar imaging system that has been your faithful window into the unseen. The next stretch of your journey isn't about gas or acid or mystery, it's about vision. About how we learn to see a planet that refuses to be seen. Venus hides everything beneath her clouds. Optical telescopes give us only brightness, never texture. For centuries, astronomers thought the surface might be covered by oceans or jungle, because no shadow or mountain was ever visible. It wasn't until the 1960s that radar gave us eyes sharp enough to pierce the veil. Pioneer Venus laid the groundwork, but it was Magellan, launched by NASA in 1989, that finally lifted the curtain. You remember reading about that mission? How it mapped 98% of the planet with synthetic aperture radar, its golden antenna dish unfurling like a sunflower in space. The images it sent back were surreal. Continents of lava plains, volcanoes taller than Everest, and fractures stretching thousands of kilometers. Venus, for the first time, became a place rather than a mystery. Historians still argue whether Magellan's data should count as photographs. Technically, they're radar reflections translated into grayscale. But semantics aside, those ghostly images revealed more beauty than any visible picture could. You've seen them before, the bright patches where radar bounces off rough terrain, the dark zones where smoother plains absorb it. They look like silver etchings on black glass, abstract and haunting. In a way, they're truer portraits than any optical image could be. Venus's reality is made of heat and pressure, not light and colour. You activate your capsule's radar array and aim downward. The beam pulses through the haze, each return drawing another contour onto your screen. Slowly, the landscape assembles, ridged plains, collapsed domes, river-like canali winding into shadow. The detail is mesmerizing. The longer you watch, the more you realize how deceptive the surface is. From orbit, it looked almost flat, but radar shows texture everywhere. Wrinkles, folds, scars. You can't help thinking that Venus's skin looks like that of something ancient, stretched thin over memory. The capsule's motion stabilizes, and you switch to oblique scanning mode, allowing you to glimpse the surface from an angle rather than straight down. The terrain looks almost three-dimensional now, rising and sinking in soft gradients. You catch sight of a corona, one of those massive circular structures formed by upwelling magma. The radar paints it bright white against the darker plains, a ring hundreds of kilometers wide, its edges cracked and uplifted. It resembles an iris, an enormous unblinking eye staring back at you. You murmur something you don't quite intend. She's looking. You think of the scientists who spent decades turning these reflections into topographic maps. Each pixel represented an echo bounced through hell, delayed by microseconds and processed by computers that could only guess at its meaning. There's poetry in that kind of patience, humans reaching across impossible distance with nothing but mathematics and hope. It reminds you of early cartographers drawing continents from sailors' rumours. Only this time the ocean was made of acid and the map was drawn in microwaves. A quirky fact bubbles up as you scan. The Magellan mission used leftover parts from earlier programs. Its radar came from a cancelled shuttle experiment, its bus from a previous satellite. Venus was mapped by a patchwork of recycled ambition. Somehow that feels fitting, our curiosity stitched together from whatever survives. When Magellan finally plunged into Venus's atmosphere in 1994, burning up intentionally to end its mission, some engineers reportedly watched the final telemetry in silence. After 4 years of data, the probe died exactly as it had lived, inside the fire. The capsule's radar finishes its sweep and assembles a composite image on the screen. You zoom in on a section that looks like cracked pavement, crisscrossed by fissures and canyons. The resolution sharpens, and for a moment the terrain resembles a city grid. Order emerging from chaos. Of course it's illusion. These are lava channels and fractures. But your mind can't help imposing meaning, sketching civilization onto geology. For centuries, people thought those patterns might really be cities. In the 19th century, Italian astronomer Giovanni Schiaparelli even imagined canali on Venus, borrowing the same term he used for Mars. We humans are pattern-addicted creatures. We see ourselves in everything, even molten rock. Historians still debate whether radar images can ever capture Venus as it truly is. Some argue the translation into grayscale exaggerates roughness, others that the data compress subtle textures into misleading patterns. But accuracy isn't the point tonight. You're not here to measure, you're here to feel. And as the radar hums and the echoes return, you feel what the first scientists must have felt: awe, confusion, and a strange affection for a world so unwilling to be known. You tilt the sensors to catch one last sweep across the northern hemisphere. The landscape below fades in and out like an apparition. It's easy to see why early maps of Venus were often circular mandalas rather than true charts. The planet invites symmetry, as if it wants to be understood symbolically instead of scientifically. Even now, staring at the radar patterns, you see shapes that could be eyes, rivers, or even letters. You tell yourself it's just noise, but part of you doesn't want to believe that. Maybe chaos itself is trying to communicate. The capsule's systems ping softly, signaling the end of the scan. You shut down the radar array and let the screen dim to black. For a moment, the absence of imagery feels like blindness. You're reminded how dependent you are on these invisible signals, how every glimpse of Venus comes filtered through instruments that translate her language for human senses. Without them, she's simply darkness and pressure, unknowable. You lean back, letting the hum of the capsule blend with the faint hiss of static. The radar has done its job. The planet's portrait is safely stored. You imagine future scientists poring over the data, extracting new meanings from these ghostly echoes. That's how discovery works, each generation tuning the same frequency, hoping to hear the universe more clearly than the last. Outside, the clouds glow faintly again, the radar pulses echoing invisibly through them like a heartbeat. You realize that every ping you've sent tonight has touched Venus directly, bounced off her skin, and returned to you. You've literally felt the planet's texture through sound. You smile at the thought. It's a kind of intimacy no photograph could match. As you ascend higher, the radar shuts down and silence fills the cabin once more. You close your eyes and picture the world below, not as a flat map of data, but as a living surface of stone and heat. The ghostly beauty of those radar images lingers in your mind. They're proof that even when a planet hides itself behind endless clouds, we still find ways to see her, not with eyes, but with echoes. You rise higher through the haze, retracing the invisible pathways once travelled by the first explorers who dared to send machines into this cauldron. The hum of the capsule feels like an echo of their determination, those engineers and scientists who stared at clouds that hid everything and thought, "Let's go anyway." Venus's history of exploration is a story of courage measured in minutes. It's also, strangely, one of humanity's most emotional sagas, half triumph, half heartbreak, and all curiosity. You flick through the capsule's data archives and call up old telemetry logs, numbers cascading down the screen like whispers from the past. Venera 4, 1967. The first spacecraft to send back data from inside another planet's atmosphere. It didn't survive to the surface, crushed at an altitude of 25 kilometers, but its sacrifice gave us our first true measurements of Venus's pressure and composition. The discovery stunned the world. Carbon dioxide thick as soup, temperatures hotter than ovens. Before Venera 4, we dreamed of swamps and seas. After it, we realized Venus was closer to hell than heaven. Historians still argue whether the Soviet Union expected success that day, or whether the transmission was luck bordering on miracle. Either way, it began an era. Between 1961 and 1984, the Venera program became an unmatched legacy of endurance. Venera 7 made history in 1970, becoming the first probe ever to land softly on another planet and transmit data back to Earth. It lasted only 23 minutes, and in that time, it rewrote textbooks. The temperature reading came through garbled at first, misinterpreted as an equipment fault. Only later did scientists realize the data were real. The planet's heat wasn't a glitch, it was a warning. The capsule shakes gently as you descend slightly, the motion lulling you into memory. You think of Venera 9 and 10, twin missions that arrived in 1975. They deployed landers that captured the first photographs from the surface of another world. The images were monochrome but mesmerizing, flat rocks under a hazy sky, illuminated by the dim light that filters through sulfur clouds. When the data reached Earth, technicians reportedly cried, not because of beauty, but because those grey stones, lifeless as they were, proved that human ingenuity could reach into places no human could survive. Then came Venera 13 and 14 in 1982, the most ambitious of them all. They didn't just photograph, they listened. Each carried microphones that captured the sound of a wind moving through dense air, soft, almost musical hissing that played back across Soviet control rooms like a lullaby from hell. Venera 13 lasted 127 minutes before succumbing to the heat, a record that still stands today. During its final moments, it transmitted colour images, the first ever from Venus. The rocks appeared orange and brown, the sky a heavy yellow. The probe also analysed soil, confirming basaltic composition. Volcanic, ancient, expected and yet completely alien. You imagine the tension in those control centres. Rows of scientists hunched over flickering screens, every beep of telemetry a heartbeat. They knew the landers were dying. The heat would cook their circuits, the pressure would crush their frames. And still, they listened, minute by minute, until the final signal faded into static. That's the paradox of Venus exploration. Every success is designed to fail, every triumph short-lived. You can almost hear the ghostly applause of all those engineers who built beauty to melt. Meanwhile, across the world, NASA was trying to understand Venus from above rather than below. The Mariner 2 flyby in 1962 was the first successful interplanetary mission, proving that the planet's surface was searingly hot. The Pioneer Venus missions in 1978 sent both orbiters and atmospheric probes, mapping the planet's pressure layers and chemical composition in detail. Their findings laid the groundwork for Magellan's radar survey years later. The United States and the Soviet Union weren't just rivals then. They were twin artists painting the same infernal muse with different brushes. Historians still debate whether the Cold War competition accelerated Venus exploration or doomed it. When political urgency faded, so did funding. After Magellan burned up in 1994, Venus became quiet again, a forgotten neighbour. Decades passed before new missions returned. The European Venus Express orbiter arrived in 2006, studying atmospheric dynamics and confirming the wind's superrotation. Japan's Akatsuki, launched in 2010, struggled for 5 years before finally entering orbit, a triumph of persistence that felt almost poetic, a spacecraft literally lost and found again. A quirky but delightful footnote. One of the Venera descent capsules carried a small medallion engraved with the hammer and sickle, a symbol that now lies melted into Venus's basalt, the first human artifact on another planet. Somewhere under those clouds it still rests, a relic of Cold War idealism fused into alien rock. Historians like to say it's the most inaccessible monument ever built. You check your capsule's internal clock and realise hours have passed while you've been floating in recollection. The hum of the systems mixes with your own thoughts, turning memory into melody. There's something deeply human about the idea of sending fragile metal boxes into places designed to destroy them. It's almost ritualistic, our offering to the unknown. Venus demanded bravery and got it in spades. The wind outside swells, brushing against the hull in long resonant waves. You imagine the voices of those long-gone missions riding on that wind, their signals still drifting faintly through space, growing fainter with every century. In reality, radio waves don't last that long. They scatter, fade, disappear. But imagination doesn't care about physics. You like to think their echoes are still out there, somewhere between the stars, whispering coordinates and temperature readings to anyone willing to listen. A small light flickers on the console, data upload complete. The capsule's onboard recorder now holds your observations alongside those from half a century of explorers. Your log will join theirs, a new layer in the ongoing story of humanity's fascination with the Golden Planet. You think of those Soviet engineers, of NASA's radar scientists, of Japan's patient mission controllers, and smile. None of them ever really left Venus behind. They just kept the signal alive until someone like you could follow it. Outside, lightning flashes faintly within the clouds, silent but bright enough to outline the capsule in white for an instant. You take it as a nod of recognition from the planet herself, a brief handshake across time. The old explorers touched her first, but tonight, you're the one carrying their memory through her skies. Venus has melted landers, swallowed probes, and silenced countless radios, yet here you are, still listening. That might be the purest definition of exploration, knowing the silence will come and daring to speak anyway. You drift higher into calmer air, the capsule's hull no longer creaking under the weight of pressure, but sighing with relief as it meets gentler winds. The golden light here is steady, diffused evenly through the haze, as if the entire sky were one endless sunset. You're hovering around 55 kilometers above the surface again, right where the atmosphere softens into something strangely familiar. The instruments confirm it. Temperature near 25 degrees Celsius, pressure just under 1 atmosphere. For the first time since arriving, Venus feels almost welcoming. This is the altitude dreamers call the habitable zone of the clouds, a ribbon of air where humans might one day live, not on the planet but above it. You switch off the capsule's rotation and let it float freely, imagining how it would feel if this tiny vessel were part of something larger, a city suspended in mist. The idea isn't fantasy, it's engineering. Back on Earth, NASA and Roscosmos once proposed aerostats, enormous airships made of heat-resistant material, each carrying laboratories, solar farms and greenhouses. Since Earth's air mixture of nitrogen and oxygen is lighter than carbon dioxide, such habitats could float naturally here, like balloons rising above the sea. You picture them gliding gracefully across the horizon, their silver hulls gleaming like slow-moving stars, solar panels tilted toward a dimmer sun. Entire communities could drift here, safe from the furnace below. Historians still argue whether the first mention of floating cities on Venus came from the 1970s Soviet studies or the later American Havoc high-altitude Venus operational concept designs. Either way, the concept persists because it's irresistible. Imagine living in an environment so extreme that your civilization must hover forever, never touching ground. It sounds poetic and terrifying at once, a world where the only choice is to keep floating or fall into oblivion. You activate a projection on the console, layering architectural mock-ups over the cloudscape outside. Towers, domes and walkways appear as holographic outlines against the mist. The simulation fills the cabin with ghostly structures, each swaying gently as though anchored to the wind. Below, golden turbulence moves like a living ocean. You can almost hear the faint hum of turbines, the chatter of scientists observing the world beneath them. A quirky detail you remember. In the early 1980s, engineers proposed using sulfuric acid itself as a potential resource. The plan was to harvest it, break it down chemically, and extract water and oxygen for fuel. In other words, Venus might one day power her own explorers with the very poison that once defined her. You can't help but grin at the symmetry. Humanity's tendency to turn danger into utility is our most charming flaw. Your instruments ping softly. Acid levels outside remain lethal, of course. The comfort of this altitude is relative. Any exposed metal corrodes within minutes, and polymers dissolve in hours. The floating cities of imagination would need skins woven from miracles, fluoropolymers, carbon composites, self-healing membranes. Even then, maintenance would be endless. The thought makes you smile. A civilization of perpetual repairers, living amid beauty and decay, patching their skyborne homes as the winds hum around them. You reach toward the window, letting the faint sunlight reflect across your glove. The colour is deep amber, like liquid honey stretched thin. In the imagined future, this light would be what citizens of Venus wake to each morning, diffused, soft, eternal dusk. The ground below would remain invisible, a myth told in schools. There's a surface down there, children, but it's not for us. Maybe the word ground itself would fade from their language, replaced by depth. You chuckle softly, half amused, half unsettled by how quickly imagination invents culture. Historians of science still debate whether such colonies are realistic or just the modern echo of older fantasies. The Soviets once launched balloon probes, Vega 1 and Vega 2, in 1985 that floated for 2 days at this very altitude, measuring winds and pressure before communication ceased. Those simple balloons, no bigger than a car, became the first and only human-made craft to sail on Venus's air. The data they sent back proved that this region truly is gentle compared to everything above or below, a small miracle suspended between violence and peace. You let the capsule drift toward the sunlight, pretending it's one of those ancient Vega balloons reborn. The quiet feels sacred. Every now and then, static whispers through the communication array, just background radiation, but your imagination translates it into voices. Maybe engineers from the past, maybe future settlers murmuring about crops or oxygen reserves. You smile again. Venus turns every rational thought into daydream within minutes. A thought surfaces. What would daily life be like in a floating Venusian city? Children drawing maps of air currents instead of rivers. Farmers tending algae that filter carbon dioxide. Scientists watching the lower clouds shimmer with lightning far below, as if the underworld were celebrating them. Night and day would blur because the light here never fades completely. It simply glows with different moods. Even sleep would feel like suspension, rocking gently in the endless gold. It's easy to imagine art thriving here too. Poetry written in vapor, music composed to mimic the rhythm of the winds, architecture designed to flow instead of stand. Venus would teach humans to build like clouds, ephemeral yet resilient. Maybe that's what this planet has been trying to tell us all along. Permanence is overrated. Your instruments remind you that energy would be plentiful up here. Sunlight diffused but abundant. Solar power easily harvested. Water could be mined chemically from the atmosphere itself. The city could sustain itself indefinitely, drifting for decades without touching the inferno below. The real challenge wouldn't be survival, you realize. It would be remembering why anyone wanted to come here in the first place. Venus is seductive in her stillness. Give her time, and she'd lull even the most determined explorer into forgetting Earth altogether. You check the altitude again, still stable, floating in equilibrium. The capsule's shadow, a faint darker patch, wavers below on the clouds. You realize this is the closest anyone can come to seeing their reflection on Venus. A shadow upon vapor, intangible, fading with each ripple of wind. You stare at it a moment longer, oddly moved. Maybe someday that shadow will belong to a city, not a single traveller. Towers will gleam through this haze. People will look down at the molten world and up at the dim sun and realize they live between two fires, one below, one above. That's the future Venus promises, not paradise, not punishment, but perspective. A reminder that even in the harshest places, imagination can float. The capsule drifts onward, and your eyes grow heavy. The winds cradle you like a slow tide, and for a moment, you almost believe you're already part of that imagined city. One quiet dreamer suspended between heaven and hell, surrounded by light too soft to end. The capsule continues to float within that amber calm, a lone speck in an atmosphere that stretches endlessly downward. You glance at the clock and realize you've been on Venus for what would count as an entire Earth day, and yet by Venus's measure you haven't even seen an hour pass. Time here behaves differently. The planet spins so slowly that one full rotation takes 243 Earth days, longer than its year. A single sunrise lasts weeks, and dusk stretches on for months. You imagine standing on the surface, watching the sky glow in slow motion, the light creeping across the horizon like spilled honey. It's beautiful in theory, but in practice that kind of day could drive anyone mad. Venus's rotation is not just slow, it's backward. The sun rises in the west and sets in the east. Historians still argue whether the planet flipped over due to a colossal impact or gradually turned from gravitational tugging by the sun. Whatever the cause, the result is surreal. A world where time loops differently, where day and night lose all meaning. For future explorers, managing circadian rhythm here will be a scientific as well as psychological challenge. The human body simply isn't built for sunsets that take 60 Earth days to finish. The capsule tilts slightly, revealing the horizon in a slow arc. The light there is stunning, soft gradients of orange fading to burnt gold. At this altitude, the sun appears only as a pale glow behind layers of haze, but you can still tell it's moving, ever so slightly, painting the sky with warmth. Somewhere far below, the surface glows faintly, radiating the heat it never stops receiving. You think about how each spot on Venus's ground endures hundreds of continuous days of sunlight before darkness ever returns. No wonder the rock itself glows. You can't help smiling at the absurdity of it. A planet where the day is longer than the year. If you lived here, you'd celebrate your birthday twice before seeing another sunrise. You chuckle softly, jotting the thought into your log. Venus, where time forgets its manners. The humour feels fragile, like a paper lantern in wind. Here, even jokes stretch into metaphysics. The slow rotation does strange things to the atmosphere. Because the planet barely spins, its Coriolis forces are weak, and yet the winds race at hurricane speeds. It's a paradox that scientists have spent decades trying to explain. Some think the atmosphere's superrotation compensates for the planet's laziness, distributing heat so evenly that day and night become almost indistinguishable. Others think it's the result of complex wave patterns in the upper clouds. Historians of science still debate which came first, the slow spin or the fast air, as though Venus herself is toying with their equations. As your capsule drifts, you realise you've entered the border between two symbolic times, the planet's eternal day above and its endless night below. The sunlight here scatters through the haze like dust through amber resin, while beneath, the darkness grows thicker, absorbing colour until only a dim reddish glow remains. You wonder what night even feels like down there. Would the absence of sunlight bring relief, or would it just trade gold for gloom? It occurs to you that on Venus, shadows never move quickly. Everything changes in slow motion. The way light creeps, the way heat flows, the way the winds carry brightness from one hemisphere to another. Imagine watching your own shadow slide across the ground for months on end, slower than the growth of moss. Maybe time itself would feel heavier here, each minute stretched like warm taffy. You'd lose all sense of urgency, all rhythm. It's a world that doesn't rush. You adjust your sensors to record the ambient light spectrum. The data reveals a surprising truth. The daylight here is closer to what Earth experiences during sunset, all the time. No harsh blue rays, no piercing brilliance, just a perpetual golden dusk. It's strangely soothing, though the knowledge that it's produced by a sky of acid dampens the romance. You muse that artists would love this planet, while meteorologists would have nervous breakdowns. The capsule rotates slowly, giving you a panoramic view of the upper haze. From one angle, the sunlight flares softly through the mist. From another, the planet's shadow stretches upward, painting the clouds in deep ochre. There's no true horizon here, just a seamless blend of light and texture. It reminds you of oil paintings, Turner's seascapes maybe, or J.M.W. Turner's fiery sunsets. Venus would have been his muse, beauty born of chaos. A quirky fact surfaces. In 2001, scientists used infrared imaging to watch the planet's night side glow faintly with thermal radiation. They called it infrared lightning, though no bolts were involved, just heat escaping unevenly. That slow pulse of red light became a kind of heartbeat in the data, the only visible change in a world where change is glacial. It's comforting to know that even in darkness, Venus glows from within. The capsule's external sensors register a shift in wind direction, subtle, barely noticeable. It's the planet's strange rotation playing tricks again, turning your sense of direction upside down. East becomes west, day becomes night. Everything swaps places. You check the compass, laugh quietly when it spins in confused circles, and decide that direction is overrated anyway. On Venus, only altitude matters. Up means life, down means death. Everything else is philosophy. You take a deep breath, exhale slowly, and try to imagine the rhythm of a Venusian day. Perhaps settlers in those future floating cities will divide time not by the sun's position, but by sound. The pulse of turbines, the hiss of wind. Morning might mean when the generators start, evening when the solar panels dim, or maybe they'll abandon time altogether, living instead by cycles of rest and curiosity. The idea feels oddly freeing. The horizon glows again, faint but persistent. You realise you're witnessing one of the planet's rarest spectacles, the double dawn. Because of Venus's slow spin and thick atmosphere, sunlight refracts and bends so much that dawn appears twice, once as scattered light creeping through the haze, and again as the true sun finally emerges. It's a trick of physics and patience. You catch the first shimmer now, a faint brightening, like the planet itself inhaling. You watch quietly as the golden hue deepens, the clouds glowing as though lit from within. It's not a sunrise as much as a gentle awakening. No sharp shadows, no sudden brilliance, just a soft blooming of light that feels eternal. You find yourself whispering without realizing it, "Good morning," even though it's a greeting that will last for months. As the capsule drifts upward through that luminous haze, you think of time differently. Not as something to count, but something to feel. On Venus, every moment expands. Every second lasts long enough to notice, and perhaps that's the secret she keeps. In slowing the world down, she teaches you to see it more clearly. The golden horizon softens into a deeper tone as you ascend, the sun's faint light scattering through layers of acid mist that shift like curtains drawn over memory. The capsule hums quietly, balanced in the still air between dream and reality. Down below, the faint pulse of the volcanic plains glows. Above, the clouds bloom outward into lighter shades of peach and cream. This is the Venus most people never imagine. Not the scientific hellscape, but the mythic one. The planet of love, beauty and temptation that captured the hearts of poets, long before telescopes exposed her scars. You glance at the control screen and think how strange it is that humanity named its most hostile neighbour after our gentlest goddess. The connection between Venus the planet and Venus the goddess stretches deep into human time. The ancient Babylonians called her Ishtar, the star of love and war. The Maya knew her as Noek, the great star that heralded both romance and disaster. For the Greeks, she was Aphrodite, born from sea foam and carried on a scallop shell. The image still immortalized in Botticelli's painting, all soft light and serenity. You imagine showing Botticelli this version of Venus, sulfuric clouds, molten seas, temperatures that melt lead. Would he still have painted her as beauty incarnate, or would he have given her the eyes of a volcano? Historians still argue whether the Romans named the planet after the goddess because of its brightness, or because its movements resembled a celestial heartbeat, appearing as the morning star, vanishing, then returning as the evening star. For ancient astronomers, Venus was a paradox. 2 stars, 1 spirit. They charted her movements carefully, noticing her strange rhythm, 584 days between reappearances. The Aztecs treated those cycles as omens, timing ceremonies and wars to her return. The planet's glow was not just light to them, it was instruction, rhythm, meaning. You pull up a holographic map of Venus's orbit, tracing how she dances around the sun, closer than Earth but moving faster, never straying far from the dawn or twilight sky. No wonder she became a symbol of desire, always visible yet always unreachable, a cosmic tease. That duality still defines her. Even now we gaze at her brilliance through our telescopes and forget the truth hiding beneath, beauty built from fury. The capsule drifts through a rare calm pocket, the air still enough that you can hear faint static from the comms array, a gentle hiss like whispers in the next room. You think about how myths once painted Venus as both creation and destruction. To the Romans, she embodied fertility and life. To sailors, her glow was a navigational blessing. Yet the same light marked the beginning of the day, an end to dreams. Venus is the planet of love, yes, but also of awakening, of harsh illumination. You grin faintly at the irony. Even in mythology, she never let anyone sleep too long. A quirky fact from art history pops into your mind. For centuries, artists painted Venus surrounded by doves, roses, and seashells, symbols of purity and renewal. Yet, early alchemists saw her differently. To them, Venus represented copper, the greenish metal that tarnished easily, soft yet radiant. They associated her with chemical change, corrosion, transformation. If those alchemists could see the real planet, they'd be thrilled. Venus is corrosion incarnate, a world literally gilded in acid. Every metal here tarnishes within minutes. Even copper wouldn't last long in her embrace. You can almost hear the alchemists laughing. The goddess of beauty is also the queen of decay. The capsule tilts slightly, its sensors picking up faint electromagnetic disturbances. You check the readings, harmless fluctuations in the ionosphere, but the timing feels poetic, as though the goddess herself is shifting her attention. You look outside again, and for the briefest instant the sunlight catches the clouds just right, forming a halo around the capsule. It's unearthly, this radiance. Soft, symmetrical, golden white. You whisper, "Venus," and the name fits perfectly, rolling through the cabin like a spell. It's strange how mythology lingers even in science. Every time you say Venusian atmosphere or Venusian geology, you're unconsciously invoking a goddess. The ancient and the empirical share the same vocabulary. Historians of science still debate whether myth hindered early astronomy or inspired it. After all, the first people to track Venus weren't scientists but storytellers. They measured her beauty not in Kelvin or kilometres but in longing. You suspect that same longing still drives us now, we just disguise it behind data. You think of the ways artists through time reimagined her. In Roman mosaics she rises from waves, in Renaissance canvases she reclines among silks. In modern cinema she's reinterpreted endlessly. Love, danger, obsession. No matter the century, Venus always demands projection. And here you are, floating above her real self, surrounded not by silk but by sulfur. And still, she feels seductive. The pull isn't just gravitational, it's emotional. Every planet inspires curiosity, but Venus provokes confession. The capsule's lights dim as clouds thicken again, the golden hues fading into dusky amber. You sense the presence of the planet more than see it now, a vast body beneath you, silent and waiting. You realize that what mythology got right isn't the beauty but the awe. To stand or float within this world is to feel small in the most exquisite way. Venus has always been about surrender, to love, to heat, to mystery. You finally understand why ancient cultures revered her and why modern science keeps returning. She's not just a planet, she's a mirror, reflecting our obsession with both creation and destruction. The console flickers briefly, showing temperature data scrolling by. You barely register it. Your attention is caught by the faint glimmer of lightning deep in the lower clouds. It flashes and fades like a heartbeat. For a second, it feels like the planet is breathing in rhythm with you. You whisper, "Still beautiful," and mean it. A thought lingers as you watch the horizon blur again. Maybe every civilization invents its own Venus. The ancients turned her into a goddess. We turned her into data. The meaning changes, but the fascination doesn't. She's always been our reflection, the side of ourselves that dazzles others even while burning from within. You set the capsule to auto-stabilize and close your eyes for a moment. The soft golden light seeps through your eyelids, warm and steady. If mythology teaches anything, it's that love and ruin often come from the same place. Here, surrounded by clouds of acid and the faint hum of life support, you finally understand the irony. Venus, goddess of beauty, lives inside a furnace, and she still glows. You rise through a corridor of light and haze where the air glows gold and bronze in layered sheets until the capsule levels out in near stillness. From here, you can almost forget that below you lies a world of molten stone. Venus stretches endlessly beneath the clouds, and in its vastness you begin to sense a strange familiarity, the recognition of a sister you've never met. The comparison to Earth has haunted science for centuries, and now, suspended between sulfur skies and silence, you finally understand why. The two worlds are twins born from the same cosmic nursery, nearly identical in size, density and composition, and yet one became a cradle for life, the other a cautionary tale carved in fire. You call up the comparative data on the capsule's console. Side by side, the numbers are uncanny. Venus is just 5% smaller in diameter, 90% as massive, and its gravity would feel almost the same as Earth's beneath your feet, if your feet could survive standing there. The chemical ingredients of both planets are similar: iron, silicon, oxygen, magnesium. Billions of years ago they might have looked alike from orbit, blue oceans glimmering, white clouds drifting lazily in sunlight. Historians still argue whether Venus truly possessed seas, or only brief epochs of rain. But either way, something happened that forced one sister into madness while the other stayed serene. Theories abound. Some say the sun's brightness increased too quickly, boiling Venus's early oceans until water vapor, a powerful greenhouse gas, fed the heating in a deadly spiral. Others claim Venus's slow rotation let heat accumulate unevenly, destabilizing its climate. A few propose that enormous volcanic outgassing poisoned the sky, filling it with carbon dioxide until it became its own prison. You stare at the data and think of family dynamics. Same upbringing, different choices. One sister learned balance, the other never stopped burning. A small smile touches your face at the memory of how early astronomers once called Venus Earth's twin. They meant it optimistically, envisioning jungles, rivers, maybe even continents teeming with life. You remember one particularly enthusiastic 1950s pulp novel that described Venusian mermaids dancing through purple swamps. The reality, of course, turned that dream to ash. Still, there's comfort in knowing that hope preceded disappointment. It means we approach the unknown with optimism first. The capsule adjusts course slightly, drifting into a smoother air current. Through the viewing port, the clouds appear less turbulent, their texture like brushed satin stretched to infinity. You catch yourself wondering whether Earth could ever become this, a world of runaway heat and endless haze. The scientists who study climate models often use Venus as a warning, a mirror held up to our own atmosphere. They call it the Venus syndrome, a phrase that sounds like science fiction until you realise it's just thermodynamics with bad manners. If too much carbon builds up, if oceans vanish, if balance tips too far, this is the end state, a planet that forgets how to cool. You whisper softly, "She's what we could be," and the thought chills you more than the capsule's recycled air ever could. Historians of science still debate how much comfort or terror we should take from the Venus-Earth comparison. Some argue that studying Venus helps us appreciate how fragile Earth's equilibrium really is. Others think the two planets diverge so early that comparing them is like comparing apples and blowtorches. Yet the resemblance remains undeniable. The same gravity, the same age, the same cosmic ingredients. Two coins flipped by the same hand, landing on opposite sides of fate. You adjust the holographic overlay to display both worlds simultaneously. Earth glows blue, haloed with clouds. Venus shines yellow-white, featureless except for faint patterns where radar has revealed her scars. From this vantage, they look like siblings caught mid-argument, one calm, one furious, neither entirely innocent. You imagine the solar wind flowing past both, buffeting them like waves slapping two boats tethered in the same storm. A quirky tidbit: early space artists often painted Venus with oceans not because of data, but because it felt right. They assumed twin planets must share beauty as well as biology. When the Mariner and Venera missions shattered that illusion, artists simply pivoted. Their next painting showed Venus as an infernal landscape, glowing orange under lightning. Humanity never stopped romanticizing her. We just changed the genre from utopia to tragedy. You check the capsule's sensors again. The air composition data streams steadily. 96.5% carbon dioxide, 3.5% nitrogen, trace sulfur dioxide. Not so different from Earth's volcanic plumes, just scaled up to planetary size. You imagine Earth covered by 1,000 erupting volcanoes and realise that's basically what Venus is. A world frozen mid-eruption, atmosphere thick with its own exhalation. If Earth ever lost her oceans, if weathering ceased, our planet would follow the same path. The thought is both horrifying and humbling. The capsule's AI softly announces that you've reached the altitude where pressure and temperature most closely match Earth's surface conditions. You glance at the readouts, 20 degrees Celsius, 1 atmosphere, and smile at the irony. Here, in a place where acid rains and lightning brews, there exists a narrow band of comfort, a fleeting reminder of home. You imagine an astronaut floating outside, arms outstretched, tasting that balance for a moment before the acid dissolves their suit. Even in hell, there's a middle ground. From here, the view expands, and for the first time you can see the faint curvature of the planet below, a disk of burnished gold fading into shadow. You think of Earthrise, the famous photograph of our own world seen from the moon, and realise there will never be a Venus rise. The planet hides too completely. She allows no one to gaze upward from her surface. Her sky is opaque, her horizon eternal. She is privacy incarnate. You find yourself musing again about siblings. If Earth and Venus were people, Earth would be the calm elder sister who learned restraint, while Venus would be the passionate one, unpredictable and untamable. You can almost imagine them speaking, Earth whispering, breathe, and Venus replying, burn. The capsule rocks gently as turbulence passes below. You take a long breath, letting the filtered air fill your lungs, and for a fleeting instant, gratitude washes over you, for oceans, for rain, for skies that change. The twinship of these worlds is more than scientific coincidence, it's moral geometry. Venus reminds you how delicate balance is, how easily abundance turns to excess. The console pings softly, signalling stable altitude. Outside, the haze glows faintly, a soft halo marking the invisible border between two destinies. You whisper, "Thank you, sister," and let the capsule drift. Because sometimes the best way to understand your own home is to listen to the one that didn't survive it. The capsule steadies itself in the high atmosphere, the hum of the engines fading into a low, steady vibration. The horizon is a blurred ring of light, soft gold melting into orange, then into grey. Up here, where the clouds thin and the glare of the sun begins to reclaim its strength, you feel as though you're hovering at the edge of a heartbeat. Venus is quiet, but you can sense something beneath the stillness, an internal rhythm, a pulse moving through rock and magma deep below the surface. The instruments call it seismic activity, your imagination calls it breathing. You adjust the capsule's radar altimeter and activate a suite of sensors tuned to measure gravitational variations and subtle ground deformations. It's a trick scientists have used for decades, reading a planet's heartbeat from orbit. When Magellan mapped Venus in the early 1990s, it not only charted her shape but also hinted at density differences beneath the crust, regions where mass seemed to shift, as if the interior were flexing ever so slightly. For years, geologists debated what that meant. Was Venus's crust completely frozen, locked into permanence, or did it still move, still stretch and sigh like Earth's tectonic plates? Historians still argue over the question, each generation of scientists inheriting the debate like a family heirloom. You send a low-frequency radar pulse downward, waiting for the echo. The signal travels through the thick air, bounces off the surface, and returns delayed, distorted but rich with information. The computer processes the data, generating a holographic cross-section of the crust. It glows faintly above the console, layered strata of dense rock, fractured and uneven. There, faint fluctuations, a ripple in the crust. It could be noise, it could be data. But it looks a lot like movement. You think of the great mountain ranges mapped decades ago. Maxwell Montes, Ishtar Terra, regions where radar brightness and elevation suggested something beneath was pushing upward. Some scientists believe these are still rising plateaus, formed by mantle convection pressing against the surface. Others insist they're ancient relics, frozen mid-motion. The argument continues, like the tremor that never ends. You imagine the ground below, black molten veins of basalt pressing upward, caught between wanting to erupt and being smothered by the crushing atmosphere. The capsule's sensors pick up faint magnetic oscillations like whispers. Venus no longer has a strong magnetic field. Her core spins too slowly to generate a dynamo like Earth's. Without that shield, the solar wind batters her directly, stripping away particles and shaping the upper atmosphere into a ghostly tail. But traces of magnetism linger, fossil fields locked into the crust from an earlier, more active age. The instruments detect their faint signatures, patches of north and south tangled together like old scars. You realize you're literally listening to the ghost of a planet's past life. You record the readings and overlay them with gravitational anomalies. A pattern begins to emerge, small rhythmic fluctuations across a region near Beta Regio, one of the planet's highlands. The differences are minuscule, measured in fractions of milligauss, but they repeat. It's as though the planet is twitching. You lean forward, pulse quickening. On Earth, such periodic patterns would suggest convection cells, mantle plumes rising and falling. Could Venus still have those? A quirky fact comes to mind. In 2023, scientists used radar data to show that a volcanic vent on Map Mons had changed shape, likely from an eruption. Later studies showed that the region's gravity field also fluctuated slightly afterward. It was the closest we'd come to confirming that Venus was still alive geologically. You grin, thinking how fitting it is that the planet of love communicates through heat. She doesn't talk, she smoulders. The capsule shifts slightly as a pressure wave passes through the atmosphere. A distant storm perhaps, or a convection surge from below. You imagine how the ground might flex when that heat builds up, the crust expanding like a lung-inhaling magma. You close your eyes, letting the hum of the sensors merge with your heartbeat. For a moment, the rhythms sync. It's easy to anthropomorphize a planet, especially one that mirrors Earth so closely. If our planet hums with life, perhaps hers hums with memory. Historians of science have long debated whether Venus ever had tectonic plates like Earth's. The evidence goes both ways. The tesserae, the ancient folded highlands, suggest compression and motion. But the lack of subduction zones argues otherwise. Perhaps the entire surface acts as one giant plate, occasionally softening and breaking, then cooling again. Some propose a stagnant lid model. Every few 100 million years, Venus's crust melts and resurfaces completely, erasing its past. If true, that means every trace of her history vanishes in cycles of fire. A planet without fossils, without continents, without memory, reborn in her own lava. You glance at the holographic model again, tracing your finger along the simulated fractures. Each line represents stress, tension waiting to release. You whisper, "You're still breathing, aren't you?" And the console answers with a small vibration as new data arrives. The gravitational field dips slightly, a minuscule shift but real. It could be a new uplift, or the settling of cooled lava. You'll never know for certain, but you like the idea that somewhere below something is still moving. A small laugh escapes you, quiet but genuine. You think about how human scientists argue passionately over data, each convinced their interpretation is the correct one. Meanwhile, the planet itself doesn't care. She keeps flexing, expanding, contracting, following her own rhythm indifferent to debate. You imagine Venus rolling her golden eyes every time we publish another paper about her mysteries. Outside the window, lightning flickers faintly, illuminating the clouds in brief, ghostly flashes. The timing almost matches the gravitational pulses. A coincidence, but it makes you shiver. For an instant, you can almost visualize the connection. Energy rising from the core, reaching upward as light. The entire planet becomes a conductor, a living circuit. The lightning fades, leaving the afterimage of veins in your vision. You lean back in the pilot's chair and let the data flow continue on autopilot. Numbers scroll across the screen. Pressure, density, magnetic anomalies. All signs of a system that refuses to rest. Venus, for all her heat and fury, is dynamic, not dead. She's the kind of world that dreams of eruption. You smile at the thought. Even if we never fully understand her, knowing she's still restless feels right. It means the universe hasn't given up on motion or on mystery. As the capsule steadies, the instruments emit one final ping, a deep, slow oscillation echoing up from the surface. Maybe it's just atmospheric interference. Maybe it's the planet's own sigh. You listen closely, hearing the faint hum fade into silence and then whisper, "Still alive." For a brief second, the cabin lights flicker in time with the final pulse, as if Venus herself agrees. You rise higher through the amber haze, leaving behind the seismic murmurs and molten dreams. The capsule's instruments click softly as they recalibrate for the upper atmosphere, and with each gentle rotation, the planet below looks a little less like a landscape and more like an idea, a swirling sphere of mystery wrapped in gold. Up here, you're at the frontier of possibility. The next generation of explorers, scientists, and dreamers is already preparing to return to finish what Venera, Pioneer, Magellan, and Akatsuki began. You take a slow breath and bring up the newest mission roster on the holographic display: Veritas, Da Vinci Plus, Envision. The names glow softly in the dim light like constellations of intention. Veritas, the Venus Emissivity, Radio Science, INSAR, Topography and Spectroscopy mission. A mouthful, but its purpose sings in its name: truth. Its radar will map the surface with precision never achieved before, capable of detecting rock compositions and even changes in the crust. It will look for signs of tectonic activity, volcanism, and clues about how the surface renews itself. Historians still argue whether Magellan revealed the whole story, but Veritas will add colour to the grayscale. The mission's design is almost poetic, to find out whether the planet of love still has a heartbeat. Next comes Da Vinci Plus, short for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging. You grin at the acronym. NASA loves a good acronym almost as much as it loves a challenge. This probe will plunge through the atmosphere, tasting it layer by layer, measuring gases and isotopes to decode the planet's origin. It will even capture photographs as it descends, glimpses of terrain no human eye has ever truly seen. If all goes well, the probe will send back a portrait of the tesserae, those enigmatic highlands that might hold the story of ancient water, perhaps even the planet's last memory of oceans. It's a one-way trip, of course. No machine has ever survived long on the surface. But the data it sends in those final minutes will be priceless, a modern echo of the Venera bravery from half a century ago. Then there's Envision, the European Space Agency's contribution, a radar mapper with a geophysical twist. It will peer through the clouds to study the planet's interior, tracing gravitational variations and searching for signs of mantle plumes. In essence, it will listen to Venus's core. You love that thought, the idea of humanity building instruments not just to look, but to listen. These missions, planned together, form a conversation between technology and myth, between our desire to understand and the planet's stubborn refusal to explain. You let the capsule drift while scrolling through simulated renderings of each spacecraft. Veritas with its elegant radar dish, Da Vinci plus descending like a silver raindrop, Envision sweeping the sky in slow circles. The designs look almost fragile, delicate butterflies against a storm, yet they embody something fierce, the persistence of curiosity. Humanity keeps returning to Venus, even after she's burned every visitor alive. You can't help but laugh quietly. Love, it seems, really does make us irrational. A quirky tidbit you recall, Veritas nearly didn't happen. For years it was passed over in favour of other planetary missions, but the momentum never faded. Scientists kept pushing, writing proposals, refining instruments. They argued that Venus wasn't just a cautionary tale, it was a missing chapter in our solar system's history. After all, understanding how she changed could reveal how Earth might change. When NASA finally approved the mission in 2021, the announcement felt less like a decision and more like destiny finally catching up. Historians of science will someday debate which discovery reignited the world's fascination with Venus. Some will say it was the phosphine controversy, others the radar evidence of active volcanism. But in truth, the allure never vanished. It merely waited for technology to catch up with longing. You glance at the holographic timeline projected before you, an unbroken chain from Mariner 2 to Akatsuki to the missions yet to come, each one a hand reaching deeper into the golden fog. You imagine what the next generation of data will look like. High-resolution radar images revealing fresh lava flows, atmospheric spectra showing noble gas ratios that trace the planet's history back to its birth, gravity maps that pulse like heartbeat scans. You can already see the headlines forming: Venus is alive, oceans once sparkled here, the hidden twin speaks. But you also know that every answer will bring new questions. That's the rule of discovery, progress disguised as confusion. The capsule hums as it synchronizes its orbit with where Veritas will one day circle. You stare out into the haze, imagining another probe passing by this exact point in the near future, its instruments shining through the same clouds. It's comforting to think that exploration isn't linear. It's layered, a palimpsest of missions written one atop another. Venera burned, Magellan mapped, Akatsuki watched, and soon others will listen. A small vibration ripples through the cabin as the capsule's instruments recalibrate. You lean forward and whisper into the microphone, recording your own thoughts for whoever reads these logs later. Venus is the ghost of Earth's future, but she's also the key to our past. You pause, letting the words linger. If she once had oceans, if she once cooled and dreamed, then so did every rocky world. Maybe even more. Maybe Venus wasn't a failure story, maybe she just took a different path. A brief flash outside draws your attention. It's sunlight reflecting off something metallic, perhaps debris from an old probe, or maybe just an illusion, a sparkle of static in the dense air. You like to imagine it's Venera 13, still down there somewhere, its melted shell catching the light for the briefest second, waving at the future. The idea makes you unexpectedly emotional. You clear your throat and focus on the console again, pretending there's dust in the cabin. You picture, years from now, data streaming from new orbiters, the radar maps bright and crisp, the chemical readings definitive. Perhaps those missions will finally confirm the presence of recent eruptions or prove that tesserae were once shorelines. Perhaps they'll find a hint, just one stable isotope ratio, that whispers of an ocean long vanished. The universe rarely hands out closure, but Venus might. The capsule's computer beeps softly, signaling the end of your transmission window. You save the data, send a burst toward Earth, and imagine the signal travelling through millions of kilometres of cold space before someone in a quiet control room receives it. You hope they're drinking coffee, surrounded by blinking monitors, smiling at the numbers the way you do now. That's how all great discoveries begin, not with shouting, but with a quiet, "Oh!" You glance one last time at the glowing names on your display: Veritas, Da Vinci Plus, Envision, Truth, Curiosity, and Perspective. The future of exploration wrapped neatly in 3 words. Outside, Venus's clouds drift, unhurried and eternal. The planet doesn't care that we're coming back, but she'll make room for us anyway. And when those probes finally descend, they'll do what humanity has always done best: fall in love with something that will never love us back and learn from it anyway. You float in near silence, the capsule following a slow arc along the high atmosphere, tracing the planet's endless curve. Below, the clouds roil in soft motion, their edges glowing like metal heated just shy of melting. From this height, Venus looks almost tranquil, almost forgiving. You know better. That illusion has fooled dreamers for centuries, and yet, in the hush of this orbit, with the hum of instruments as your only company, the thought sneaks in uninvited. What if we went back? Not with robots, but with humans, breathing, sweating, marveling humans who would finally look upon the surface with their own eyes. It's not entirely impossible. In fact, there are already blueprints scattered across NASA databases and private consortiums, schemes with names that sound halfway between poetry and dare: Habitat, Havoc, Vamp. Each proposes the same astonishing idea: human explorers drifting 50 kilometers above the surface in airships made of materials immune to acid. You can almost picture them: vast silver envelopes filled with breathable gas, carrying laboratories and small crews who wake to the glow of eternal dusk. They wouldn't walk on the surface. No one could. They would sail the sky instead. Scientists turned skyfarers in the most inhospitable sea imaginable. Historians still argue whether humanity's return to Venus will happen before or after a permanent Mars settlement. Some say we'll reach back to the goddess first because she's closer, just 40 million kilometers away at her nearest approach, a cosmic neighbor. Others believe Mars's solid ground and easier conditions make it the logical next step. But logic has never been our compass. Curiosity has. The same irrational flame that drove explorers across oceans now burns for worlds made of acid and fire. You think about the engineering required: suits layered with polymer coatings to resist corrosion, breathable habitats protected by electromagnetic fields to deflect solar radiation, drones designed to glide through lightning. It sounds like madness, but so did flight once. You imagine a small team, 2 scientists, an engineer and a pilot, descending into this atmosphere aboard a massive, slow-moving ship, their reflections glinting off the portholes as they break through the sulfur veil. Their first sight would be this: the gold and rust and honey-coloured clouds turning their own light into art. They'd gasp, maybe laugh, maybe cry. You can't decide which reaction feels most human. A quirky thought flickers. If humans lived here, timekeeping would be chaos. Days longer than years, sunrises that last months, nights that never truly darken. Perhaps settlers would invent their own rhythm, counting time by wind patterns instead of solar motion. Meet me after 3 rotations of the high current, they'd say, and everyone would nod, understanding perfectly. Venus would teach us to abandon precision, to live by flow instead of tick. The capsule's altimeter dips as you descend a little to gather data from the mid-cloud layer again. Outside, the light changes. Gold deepens to amber, and amber fades to copper. The temperature rises, the pressure nudges upward, and you feel the heat seeping through the hull, gentle but insistent. You think of what it would take for humans to survive here: constant cooling, filters recycling every breath, shields humming like metallic heartbeats. The machinery would never stop singing, the airships forever murmuring with effort. Venus demands devotion just to stay alive. You picture the surface far below, blurred and unreachable, glowing faintly from its own heat. Someday, perhaps, humans will lower robotic cranes through the clouds, sending rovers capable of surviving longer than the brave but doomed Venera landers. Maybe those rovers will carry messages from the people floating above, tiny metal postcards dropped into hell saying, "We're here now. We remember you." The thought feels both absurd and tender. Historians of science often describe Venus exploration as a story of unfinished sentences. Every mission ends abruptly, burned, crushed, silenced mid-word. Sending humans might finally let us complete one. You can almost hear their transmissions, voices cracking through static describing colours and horizons for the first time. The ground glows orange, the air hums, the mountains look like waves frozen mid-tide. Those words would echo across generations, proving that even hell can be witnessed with grace. The capsule's computer pings softly, signalling the proximity of your next measurement zone. You stabilise the craft, and as you do, you catch your own reflection in the viewport, a pale silhouette against gold. It's easy to imagine this as the view from a future habitat window. People looking out, sipping coffee made from recycled vapour, wondering if the clouds below hide shapes or stories. Maybe there will be poets among them. There always are. Even in the most technical worlds, poetry finds room to breathe. You smile, thinking of what life might look like aboard those floating colonies. Gardens grown in sealed glass, fed by hydroponics and filtered light. Children tracing cloud patterns on walls, learning about the ground as a concept rather than a reality. Artists painting in shades of ochre and gold, their palettes designed to mimic the colour of acid rain filtered through glass. Venusian cuisine might be simple, lab-grown protein and greenhouse vegetables, but you can already imagine someone marketing it as cuisine au soleil inversé. Humanity never misses a chance to make even survival sound elegant. The capsule rolls slightly, the sunlight flashing across your dashboard. You think about what drives us to return to dangerous places. Maybe it's defiance, our way of saying that no world is too harsh to admire. Or maybe it's nostalgia, the pull of our cosmic twin calling us home to remind us what fragility looks like when it's stretched too far. Venus, after all, is the ultimate warning written in light. This is what happens when balance breaks. A sudden surge of wind rocks the capsule, and for a heartbeat you imagine it's a greeting, a playful shove from the planet itself. "Come back when you're ready," she seems to whisper, "but bring patience, bring humility." You nod, half smiling, half in awe. You set the capsule to ascend slowly, rising toward the pale upper layers where sunlight diffuses into silence. The thought of human explorers here feels less like fantasy and more like prophecy. One day, our voices will echo through this atmosphere, carried on radio waves and dreams. The first words spoken aloud might be something simple, something human, like, "We made it." And when that day comes, Venus won't respond. She'll just shimmer quietly, her clouds swirling like silk, her silence dignified. Because some worlds don't need to answer, they only need to be witnessed. The capsule drifts upward toward the thin edge of daylight, where the sky begins to fade from gold to a washed-out grey, and the clouds below lose their texture, dissolving into abstraction. You're nearing the upper boundary now, the place where Venus yields back to the vacuum of space, where the soundless winds flatten into silence. The instruments hum softly, collecting their final readings, but your attention isn't on the data anymore, it's on the feeling of departure. After so many hours floating through sulfur and sunlight, the idea of leaving feels oddly like heartbreak. You came here seeking knowledge, and you're leaving with something more complicated: respect, awe, and that quiet, humbling sense that some mysteries deserve to remain half-veiled. You tilt the capsule for one last look down. The haze is endless. The planet's glow spreads beneath you, radiant and indifferent. Venus doesn't care that you've measured her atmosphere, mapped her mountains, or traced her chemical secrets. She was burning long before you arrived and will keep burning long after you're gone, but you can't help whispering your gratitude anyway. Thank you for letting us look. It's not science, it's ritual. Every explorer talks to the silence eventually. Historians still argue whether exploration is an act of reverence or intrusion. Were we right to pierce the clouds, to send metal hearts into a world that asks for none of this attention? Or is curiosity the closest thing we have to faith, a belief that understanding the universe makes us part of it? You decide it's both. The capsule, the data, even your heartbeat. They're all offerings to the same instinct that made early humans look up at the bright evening star and name it after love. The light around you sharpens as you breach the top of the atmosphere. Above, the blackness of space returns, streaked by the distant white of Earth's sun. You rotate the capsule to face homeward. From this angle, Venus looks serene, glowing like a perfect pearl. If you didn't know better, you'd think it was peaceful. That illusion, beauty as disguise, has always been her gift. The very reason we called her Venus. A quirky bit of trivia rises in your mind. The planet's slow rotation means that if you stood on the surface and looked up, the sun would appear to move backward across the sky, rising in the west and setting in the east. It's such a simple reversal, yet it feels symbolic. Venus has always done everything backward. Her spin, her atmosphere, her fate. Maybe that's what fascinates us. She's the mirror that refuses to flatter. She shows what happens when nature takes the same ingredients as Earth and writes a different ending. The capsule's navigation system confirms orbital alignment. Soon the engines will fire, pushing you away from the planet's gravitational embrace. You let your gaze linger for a moment longer. The bright edge of the clouds flashes faintly, reflecting sunlight like polished brass. For a second, it looks almost like a shoreline, the memory of an ocean that no longer exists. You think back to those earlier sections of your journey, the lost seas, the tesserae, the volcanoes that breathe. Each one was a page in her story, and now you're turning the last. Historians of science still debate what Venus teaches us. Some say she's a warning, proof that climate can tip from paradise to purgatory. Others call her a laboratory for resilience, showing that even in extreme conditions, structure and motion persist. The truth, you suspect, lies between. Venus is neither villain nor victim. She's simply what happens when energy finds no escape. A planet caught forever in the act of remembering how to cool. You glance at the capsule's reflection window, catching your own face faintly mirrored against the glowing world below. It's impossible to tell where the reflection ends and the planet begins. That overlap feels right. Venus isn't just a story about a distant sphere of rock and acid. She's a metaphor for our own fragile equilibrium. Every puff of carbon dioxide we release, every degree the oceans warm, is a small echo of her long catastrophe. Studying Venus isn't only about other worlds, it's about saving our own. You adjust your trajectory, letting the autopilot engage for re-entry to the orbital transfer path. The capsule vibrates gently, the engines pulsing like a heartbeat. You watch the planet shrink as you rise higher, until the endless clouds merge into a single golden blur. In that moment, you understand why the ancients saw her as a goddess. From this distance, she looks flawless, an unblinking eye of beauty hanging in space. Only by getting close did we learn that perfection burns. The capsule's communication array hums, ready to transmit your final log. You take a deep breath and begin recording. Venus, you say softly. You are proof that love and ruin share the same roots. You remind us that brightness can hide fury, that warmth can become hunger. But you also remind us that even after collapse, there's still movement, still music in the heat. Thank you for showing us what endurance looks like. The words echo faintly through the cabin, then fade into static. Below, the planet gleams one last time, then disappears into the brilliance of sunlight. You're already moving away, accelerating into the cold dark. The stars open around you, and Earth glimmers faintly ahead, pale blue and impossibly fragile. You think of home, the sound of rain, the smell of oceans, the cool air that doesn't melt metal. Suddenly you understand that exploration isn't about leaving, it's about learning to return differently. The capsule hums with stability as the navigation lights blink in rhythmic calm. You close your eyes, letting the glow of the instrument panel blur into soft halos. The journey's noise fades into memory, the hiss of acid clouds, the whispering winds, the heartbeat of magma far below. You exhale slowly. Venus's silence has followed you out into space, a quiet that feels less like absence and more like peace. And so, as the planet recedes into the distance, you give her one final glance. A golden world wrapped in mystery, her beauty and fury intertwined forever. You whisper the closing line of your log, barely audible. From fire she was born, and to light she returns. The words hang weightless, carried nowhere and everywhere at once. Then you lean back, eyes half closed, as the capsule glides toward the deep, forgiving dark.